Dum. Hey, Mark. How you doing? Someone, a different person being the first on stream for a change. I found this. See, I was quiet, wasn't I? There's proof. I don't always mutter to myself while I'm streaming. What was that thing? Map. Was this it? Be good to get some. Oh, this could work. Yeah, this is where it was last night, I think, actually. Yeah, but yes. I haven't. I'm not actually working on this when I'm not on camera, but I've certainly fixed up the setup with the cameras. We have 3 cameras now. Camera number 1, which is looking at the System 1 display, and then there's this camera, so you can see the here, and then there's this one. 3 cameras, amazing. If I reach 4 cameras, I think there will be some kind of critical mass reached. Mark, you are in Washington, aren't you? So let's see if this works. Can I make a pin? How do I drop a pin? You have to log in to perform this action. There was another one that didn't require that, which was, I can't remember what it was called.
Hello, Dino.
Oh,
Hello, Dino.
me. Quiet, Hal. What are you doing? That was like you yelled at me. What was it called? Something map. There it is. This one. So here we go. You right, this is better. You are in somewhere around here. What was it? What? Geometry. My geometry is terrible. Type of. Oh, okay. Washington. Oh, you're in Seattle. Okay. All right. Seattle. I think I've been to Seattle once in my life. There we go. Seattle. So I can zoom this back out and we can see where the viewers are today, where the audience is today. It doesn't actually show the names though. You can see it when you hover over Mark. And then of course I'm over here. How do you add? Oh, we can do that, right. So this is in Brighton. Dino. Oh no, that's Mark. This is Dino. Get rid of that. So there's the world map right now. I've got a feeling we're not going to get any strange people coming onto the stream with weird names or from weird places. I think that has gone out of fashion. We shall see. Right, I was thinking about this game, The Endless Runner. As you can see there, it just came up as this K character. Then that made me think I can actually have the character as kind of something that can animate. And you know, this kind of actually makes sense. It's like a running man. So how can I do a running stick figure with a display like this? 7-segment display, that's a question. So I'm just thinking about that right now. I mean, I could do Yay, hi there Scott. You watched my KOR Strange and I take that as a compliment. Because I think that anything that isn't strange these days is pretty boring. Although I admit that it might be good to have a little less strange for a bit, just a respite, a little bit of a rest. But how are you doing, Scott? What was your name back then? And can you tell me where you are on the planet so I can put a little marker for you? I suppose what I could do, well, you know what I think I'm going to do, because you know this animation is important in video games. Animation, everybody knows animation is important, and I'm going to do the AAA of 8-bit don't even have a video screen game development, because as you can see here, I set up an extra camera. Just this is an Acorn System 1. Genuine, original Acorn System 1, which I restored after buying it off eBay and finding it had a broken LED in this display, but I managed to get a replacement that's identical. If I turn on that, you can actually see the display close up. Oh, Sputnik, yes, I remember. Well, good to see you again. I can't actually, no, the way I have it set up, I can't actually zoom out. But you can see there's this display there that you're looking at really close up. And there you are. With the display so tiny, each of the digits has a little dome that acts as a magnifying glass on it. It's to make it bigger. So yeah, I'm making a game for it. When I'm making it in assembler. Now, of course, the thing is that it is very important to have animation. Oh yeah, Derbyshire. Where is Derbyshire? Does it even know? Oh yes, I can go Derbyshire. And if we go in, we can see that we've got the town of Ripley. But the first thing that you can see are the two most important things that you need to know: Ripley Hospital and Sainsbury's. Over there you have the Amber Business Centre. So let's where in Derbyshire? What's C? Oh, I see. That's in Cromford. So I don't know, it came up here. I'm going to put it here, just outside of Derby. Okay, so let's. Where is Derby? Where is Derby? I don't know which direction. I'll take a guess. You know what? I want to go to Derby so I can stay at the Hotel California, as I'm quite sure there must be one. Oh, you're between that and Nottingham. If you're not near California, then. You're, let's see, ooh, I love the names, these places. Spondon, Ockbrook, Asda, Derby Supercentre, very important. That's too close to Nottingham. I'm going to put you in Ockbrook. So this is Scott, who used to be Sputnik. Good to see you again. There we are. Then we can zoom out. See, this is. I'm not afraid of technology. It's certainly easier than maintaining the map by hand. What's this? Another one. Okay. Very close. A lovely part of the world. Okay. I look forward to being able to get out and about again. But I need to wait because I'm not going to do a Barnard Castle. So, meanwhile, yes, what I'm going to do is write a game. What I'm doing is writing a game for the Acorn System 1. The Acorn System 1, first computer I ever owned, has a mighty 1K of RAM and a 1 megahertz 6502 8-bit processor. and it's the first computer I ever owned. And when you program it, you have to program it in hex. So here's the program so far, and there is so little memory, you can just put it all in a spreadsheet. So I did that. And this is the code, and you have to write the code in hexadecimal. So this is as hardcore as it gets in retro game development. This is how I taught myself programming. Yes, you can tell I'm having a near retirement life crisis. No. I've still got a bit of a way to go before I retire. I could keep going another 20 years. I mean, actually, I'm quite. I would be retirement age, I think, in 12 years now. Because, hey, Alessandro, did I write a book? I wanted to write a book about game programming, but nobody would be interested in it anymore. I should have done it like 20 years ago. There might have been some interest, but now nobody cares. Nobody cares about game programming. It'd be like writing a book about, these days it would be like writing a book about web programming. It's like, why would anybody write a book about web programming? You couldn't, because the first question is, which framework are you going to use? You have all these frameworks to use. That's why websites all look the same. You've got basically two kinds of websites. You've got websites which are made with the frameworks, and websites which look like they come from pre-2000. There's nothing really in between. Have you noticed? Was it a C16? I don't know the C16. But yes, it's one of my... I want to program all the computers I've ever programmed before. I'm going to have fun reliving how I learned to program. I don't know why. I just want to do it. So, well, that's exciting. C16, tell us about it. The Acorn System 1 was the first computer from Acorn, as in Acorn RISC machine, ARM. ARM processors come from originally the company that started their business pretty much with this. This was the first computer they released, the Acorn System 1, in 1979. And you built it yourself. So the one I had originally, I actually soldered it up myself when I was like 13. Well, do it, and you'll have more fun than learning to code with new computers. Really, learning to code with new computers is not much fun at all, because there's all the you have to go through so much red tape. It's like install Visual Studio, DirectX, install this, install that. The Windows SDK, and it just goes on and on and on and on. See, I'm kind of enjoying this. Is more fun. This is more fun. When you talk about fun, this is more fun than why? Because it might be harder, but is it any less meaningful? Not really. I'm really getting into the idea of making a game on a calculated display. Design a game on a calculated display. Why not? Because either you do something because you love doing it, or you do something because you want to get it out of the way. Well, if you want to get it out of the way, that's when you do something because you want to achieve a goal. And then if you're not careful, achieving the goal becomes the thing that's important, which means that what you're doing on a day-to-day basis is just something you want to get out of the way. And then it's not fun anymore. I was actually thinking today, it would be kind of cool if what I did was make games. And I stream making games, but I never let anybody ever play them. I really find that quite compelling. There's a purity to that I really like. I used to, because you see, it used to be I made games because I wanted people to play them. Just like I make music because I wanted people to listen to the music, and it's wrong. It's bullshit. It's like no, you make music because you want to make music. I don't care if nobody's going to listen to it. But as I've said before, the songs care, so they kind of twist my arm and make me advertise and spend money on getting the songs an audience. So the songs the songs have an ego. I don't really. I mean, it's like, what's it to me? It's a different way of looking at it. So you make a game not for or write music not for the purpose of having somebody listen to it, or a game without the purpose of making the game is have somebody play it, then you can just enjoy making the game or enjoy making the music. And I think that's better. Donating anonymously, yeah, it's the purest form of charity, absolutely. The only problem with that is that yeah, there's nothing wrong with that actually. The problem is you can't. It's not going to inspire other people to do the same, is it? Well, maybe it will if people know. Anonymous donation. Yeah, it made me think. Maybe I could do that. That's a good idea. That's a good point, Mark. Well, I suppose there's a side effect, which is not quite charity, but it's. To do my music, I engage the services of a recording studio that's nearby, a very small one, and I get on very well with the guy, Simon. It costs money to go into the studio. I do it several times a month to work on the music, because those tracks I'm putting out, they don't sort of happen by themselves. But I get a good feeling from the fact that I'm helping someone who is a professional musician by actually being their customer. That's pretty cool. I like that. Well, of course, now you know that I look at it that way, so of course that part of things is diminished. But, oh well. If I hadn't said that, it would have been purer, but now it's tainted. But I don't think he cares. So there we are. Oh well. And so Scott. Oh, Alessandro. Yeah. So I need. So which one are you? I think we have more than one Alessandro. Are you the one from Milan? Oh gosh, I forget how far north Milan is. I thought Milan was down here, but it just keeps, it's a weird. Milan seems to move every time I go and look at where Milan is. It seems to be different place to where I thought it was. Look at it. It's right near. The Como is right on the border with Switzerland. It's like Milan's really far north, isn't it? Confusing. Per Milano, ecco. Va bene, allora io ti metto. I have to get the grammar right, Italian grammar right. Ti metto. Ti metto in Milano? Or a Milano? Ti metto a Milano? Non lo so. I don't know which is the right thing there, to be honest. There, you are. Your letter for today, you are letter E. Oh, right. Someone is using your username on Twitch to donate fairly large amounts of money. It happens every 2 months. Well, that's great. But we don't know who it is. Very devious there, Refly. I do like that deviousness there. Very nice. So, io vivo a Milano, ma io volevo dire che io ti metto in Milano su questa carta. È per dire io sulla carta ti metto lì. Ma non lo so. Sorry, excuse everybody else. I've got to practice my Italian from time to time. Perché se no lo perdo. Io non voglio perdere l'italiano. Molto importante che io parlo italiano, anche perché c'è Brexit. Il problema con Brexit è che può essere, perché tutta mia famiglia è in Italia, right? I genitori, my sister, I can't remember how to say sister all of a sudden. But anyway, sono tutti lì. E con Brexit, guarda, può essere che nel futuro io devo ritornare in Italia e per quello forse è meglio che non perdo, se non perdo la lingua. Così. And for the rest of you, if you want to know what I was just saying, you can just ask Alessandro and he'd be very happy to translate for you. Won't you? Oh, Refly. Hello, Refly. Good to see you. Now, we have a map. You see, I've gone up in the technology stakes of maps here. Where are you? I actually do not remember. It's not you. Of course it's not you, Refly. Go. Where are you from? I don't remember what the 16. I don't remember ever seeing a C16. You're talking about a computer that I have no awareness of, and I saw them all. What do you mean a C16? What was this? How could I? I mean, there was the Oric one, the Compu 10, the UK 101, the Dragon, the BBC Micro, the Sinclair. ZX80, ZX81, the Spectrum, the Quantum Leap, which was a bit later, the Archimedes. But I don't remember Commodore 64. Obviously, I don't remember the C16. So it's like you're having one of those moments where suddenly something is. See. Tell me what you mean. Maybe I need to. It's Bruges. Oh, Bruges is a lovely. You live in Bruges. I didn't know you lived in Bruges, Refly. My word, I'm jealous. Bruges is a lovely city. And there was also a very good sort of gangster film called In Bruges, which I recommend. I think it was called In Bruges. And it's a bit dark, but it's actually it's a very good film. So, Bruges. So that is up here. Anko released lots
Hello,
of...
Dino.
Okay, I'm going to look up the C16. I don't remember. I don't remember the C16. Oh, look. There is a town called Mail. But you don't have to tell me exactly where you are. It's good enough for me to just go, boom. That's close and there. So, Refly. Dee. Right. So, C16 computer. Oh, the Commodore 16. I don't remember the Commodore 16. I remember there was the other one, the Commodore, which looked like that. The Commodore... Oh gosh, what was it called? Yeah, it's very similar to... I don't remember the C16. Why? We have a look there. Wikipedia. Commodore 16. Your home computer. Released in 1984. Intended to be the VIC-20. That was it. So of course the VIC. I always thought that the VIC-20 was VIC-20 and then Commodore 64. The C16 was a major failure in the US. Just that one just never got on my radar, but it looks like a VIC-20, doesn't it? Okay, interesting. You can place me at a random location near Ghent. Okay, well, Ghent is not far from... I'll put you in halfway in between. There we go. There we are, Refly. Oh, very good. Anyway, Hal, play Refly theme. Hello, Hal.
Hello, Dino.
Why are you so loud, Hal? You're so incredibly loud. You're distorting everything. Hello, Hal. Hello, Hal. Hello, Hal. I think there's something wrong with Hal. Let me go and fix Hal, because the settings, they always get screwed up. It's reading from the wrong interface. It's reading from the camera microphone. That's never going to work. Yeah, here we go. Hello, Hal.
Hello, Dino.
Yeah, that's better. Hal, play Refly theme. So these two, what I'm going to do is make my character for my game that I'm making on the System 1 use these two characters, because I have to make it with 7-segment displays, right? So make it with these two characters, and I'm going to animate them so we can have animation. I'll just have it flip between the two. I think it will kind of give an impression of something running. So the first one is going to be 7C. 7C. And this character is going to be 6. No, it's not 7C. Ah. Or is it? Yeah, it is. 7C. Yeah, it is 7C. Of course it is. That one is 6-7. because the display of the system 1 is mapped as follows. This is bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, and bit 7. So we can see that with those bits in that order, that one is 7C. No, I got it wrong. It's a good thing I checked. It's 7-3, not 7C. 7-3, and this one is 0-1-1-0 and 0-1-1-1. That's 6-7. So let's just check that that works first of all. If I go to the code here, at the moment the player character is in 22, and that isn't set by the program, so I can actually just debug by going into the monitor at address 22, and at the moment that's F5. Let's check if that makes sense. So I'm going to go and see what's F5. F, it is actually with the dot and these 3, so it would actually be I'll do it here, F, so it would set that, and 5, that, and that's exactly what I see on the screen. Commodore +4. So if I try putting these numbers in, I can just check that. Ah, and I forgot. Sorry, Mark. Because we have Mark here as well, don't we? And I forgot Mark was here first. I should have done his theme first, but I got distracted. Apologies, Mark. Hal, play Mark theme. In common with the themes that I make for people, because they're done really quickly, and they're done in GarageBand. I haven't used GarageBand in a while, but the timing on that tune is a little off. The groove is a bit weird. Maybe get game development for the Amiga, but that'd be kind of cool to do that. I might do that again. That would be nice, but I would want to do it on the original hardware, so I'd need to get myself an Amiga. So I have these two characters and I want to animate them. Now I've got a frame counter. I made a 2-byte frame counter in here already, so I can just use that to do the animation. I'm going to try it here. Oh, wait a minute. Because I had the player display the player. You know, I think I'm going to need to make different code areas just to make this manageable. So I'll do a little bit of refactoring in here. And that is clear the right-hand here, blah, 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 blah. Display the player. But what I want to do is before I display the player... Oh no, well I have to display to get the input anyway. I was thinking about lag. But the way this is set up right now, I can only respond when I get the input. So I had here environment, say a 0249. Let's check. 0249. 0249. Let's try that again. Yeah, I have some EAs in there. So what I'll do is just change this to not enemy environment, but this is going to be the player. I want to say AI, but player behavior. This always annoys me. Player behavior. I remember when I was teaching AI, I didn't like calling it AI. I called it behavior. Everything I did seemed to seems to be controversial those days. Yes, it's behaviour, because you need to learn that the even objects that you don't think of as having AI have a behaviour, like a fuel tank has a behaviour. In actual fact, what's tricky is managing behaviours, and then AI, what we call AI in video games, is actually really behaviours. Then you actually have AI, like a strategic AI for gameplay, but that is actually not that. It's a whole nother thing. You know, behavior programming, behavior management. So player behavior is going to be what I'm going to call here 0300. I need to put this in somewhere in memory. I've only got 512 bytes to play with unless I start using up stack space and variable space. So the player behavior I'm going to call 0003. So this is going to jump to there. Now of course this doesn't actually change when I change that. I have to type it in. I'm using the spreadsheet just as a keeping notes. I'm doing this like as close as possible to what it was actually like. I would write the code out on paper. So this is going to enter in 20, which is jump to subroutine, and then address 00 and then 03. And then if I go to address 0300, there's something there right now. Oh, there's always something there. That's probably a piece of old code. So this is going to be player behavior, where I will deal with the animation. Yeah, Google Sheets, the programming IDE reference thing. I could actually make something that would read the spreadsheet and turn it into audio that I could load into the Acorn, but I consider that cheating. You know, put the map on, then I can see. So did I get everybody? Scott, yes. Who's Marker D? Oh, I didn't put the name down. Sorry. It's Alessandro. Copy. Well, it's probably a bit early in the morning yet on a Sunday. Easy like Sunday morning, isn't it? We might not see, we might not get anybody. Okay, Michael, well thanks for popping in. And I seem to have missed you. Oh, you just popped in. I got you. Right. Well, you popped in, and you'll get from Manchester. There you go. How you doing? Good to see you. Look, you see, look, there's this line. It's all this line like this. Amazing. We might not get anything from Australia today. We may find Adam was here last night, but it was at 3 a.m. over in Vancouver, and we're likely to see something from Zag. I don't know if Garcia is going to show. I suspect not. Right. So player behavior. Well, this is going to be a subroutine that's going to be called, and then what I want to do is switch between the two characters that I had, so that I can animate between these two, 7-3 and 6-7. I'm going to 7-3 and 6-7. So what we'll start off by doing is looking at the frame counter, which the lowest is 20. So the least significant byte of the frame counter is 20. So let's load that in. A5 load accumulator from 0 page address 20. And then I want to AND it. Can't remember the AND. I'm going to remember. Eventually, you remember all the codes, but I can't remember this. But I've been using it here. It was 29. So code 29 is immediate AND what I've got there with the lowest byte of the frame counter. So I want to make a blinking action. I can do this by masking off to leave 1 bit. I think I will do, say, 10. That would be every, that's a bit too much, every 8 frames. No, yeah, let's leave that. There's every 16 frames. But for a full cycle. No, it's 16 frames on and 16 frames off. Okay, then I'll use 0.8. That's 8 frames on, 8 frames off. So what we'll do then is branch if not equal, which is D0. And yes. Just thinking about how to do this. I could actually A2 is load the X register with the value, which I'll get off the sheet here, of 7.3. So that's one of those characters, 7.3. And this needs to be in format plain text. So we've got A273, and then we A520, 2008, D002. So that branch if plus. Skip this instruction where I can do A2 of the other one. So a common pattern, which is 6.7. So basically, I load one of the characters, the first character, into the X register. Player behavior, animate running. So it's like take this character, so I just describe it here, flip between 2 frames. So I put 1 frame in the X register, I load the frame counter into the accumulator, I mask off all the bits except for the 3rd bit, bit 3, and then if whether or not it's equal determines whether I overwrite the 7.3 with the 6.7, which is the other character, and then I can write the X register to 0 page. Can't remember. Store the X register in 0 page is available. That's 8.6. Yes, I remember 8.6. Very familiar. So 8.6 writes the X register into 0 page 22, which is the write to player character, and then I'll just do a 6.0 here. So in this way, if I call the player behavior, and the player behavior is going to have an animation in it. Now I need to enter that in. So that was, oh, where is it? I think I have a display up here that I did as well to help, so I don't have to keep twisting my head. A273. There we go. Load X with 7.3. Load the accumulator with address 20, and that, which was 29, and that with 0.8, branch if plus, actually I can't remember now whether it wasn't branch, it was a branch if not equal, but it's the same, it doesn't matter. Yeah, it should be, actually why say plus? I didn't want plus, I want branch if not equal. I have a sheet here with the ones that are common ones. D0. I should put the others in, but whatever. I want one in there. So D0 is branch if not equal to forward by 2 bytes, which jumps around A267, which is load the X register with 67. And then I store the X register in address 22 and then return. So if I've got this right, this should now animate my character. Oh, and we have a crash. It actually crashed. I think I went through the whole of yesterday programming. I didn't have a single crash. Had a bug, but it never crashed. So that's disappointing. I've gone so far without crashing. Now I'm going to have to restart all over again. No, I won't. Let's have a look at why. Well, first of all, I can just do a very simple little check. I can put a return statement at the beginning of my subroutine 0300, replacing the A2. That's an RTIP, return from subroutine. That crashed. Now what that means is that the call that I have here is wrong. The 20.0003, that was 0249 20.0003. Then there's something else going on. What's 02? Oh. So the first EA I had at 4.4. This doesn't correspond to what I'm looking there. Things have got out of sync. 239, 239, A5, 24, C9. So that's why I crashed, because I've got a alignment between my spreadsheet and what's actually in memory. 239 is A5. A5, 24, C9, 00, D0, 03, 208002, C903, D0. Alright, this is D003. So there is a fire input check, which I'm jumping over. That's the EA. But even if I don't jump over it, those are NOPs. We should be at 249 now, where I put the player behavior. There's a subroutine call at 0003, and then we're missing 4C0402, so it was missing the jump back, because this is jump back to here. Sorry, I'm looking at the wrong one. This is jump back to there. Oh, look, if I click on this one, you can see it light up the other one. That's kind of interesting. Let's see if this works. All right, so we're going to go to address 0200. So that's working. Not crashing anymore, but it's not animating the player yet, and that's okay, because I disabled that, as you recall, because I replaced this with 6 zeros. So I'm going to reset, go 0300 memory 60, which needs to be replaced with A2 reset. That's all. I didn't need to even reset, but it's animating. Look at that. Now it's animating very slowly. Of course, it's 8 frames. So the frames are fairly slow. I mean, it can actually update pretty quickly, the display. It can update the display pretty fast. But the thing is, that I've only got 8 characters. I can't really have it update quickly, because then it'll be unplayable. So the animation code is working. To change the rate of animation, I can change this number. I can use this to actually change even the pattern a little bit, to make more complex patterns. But if I try doubling, quadruple, 02, so every 4 frames it's going to change that. So in order to change that, I need to go to 03 OA, no, 0304. I'm going to change that to 02, and then let's try it. And so there we can see, there's my animating character. Yay! You've got to have an animation system. I made my animation systems. This is for my endless runner. And he's going to be able to jump. Well, you might be asking, this piece of, this idea hit me last night as I was going to sleep. Was, if you see, the problem is if I make the character like that, then I can't make the character jump. Or can I? There's nowhere for it to jump to. No, but what I could do is simply make it retract its legs, and that would have the same effect as a jump without actually having to move it upwards. So similarly, I can have a crouch. So it's not going to go flying up into the air. It's just, it will crouch, or it will lift its legs. But that is close enough to a jump. Then as things are coming, then you'll have to duck under them, or you have to jump over them. Ultimately, that's all an endless runner is, It's like, well, that type of scrolling endless runner. It's all these game ideas, they're all the same, I mean, So time to do a bit of design. I need to talk to the art department. So hello, art department. What I'm looking for is I'm looking for the jump thing, so that and can we have it animating? Well, yes, of course you can have it animating. What do you want it to do? All right, well, we'll do a transition. We'll have, this is normal, and it will move to well, I don't know. What? Let's try it. Aha. What is the thing going to look like? I suppose we could just make it squash itself down to a bar. Hey, Mycon! Mycon! Did you have a theme? Did Mycon have a theme? I can't remember. Tell me if you had a theme. I might be able to dig it out. It's Mycon. We've got quite a few people today. Wow. So Scott, for example, who was Sputnik. Wow. How are you doing, mate? The jump sprite, unfortunately not. Oh, right. Okay. Well, keep coming, and eventually you can have a stream. One, two. Where are you? Where is Mycon? See, because I've got this map thing going here, so we can see everybody who's said something. It's not all the viewers, but it's for anybody who tells me. You can have a marker for where you are. Where is Mycon? It's good to sort of be able to remember where people are. So let me know. So I think actually the art director is just saying hi to me in my head and saying, I reckon, like he says, that we should do this, because that kind of, you still got the legs dangling. I go, oh yes. Smack everyone except Zag, who did say something. What, is Zag here? Did I miss? I didn't see Zag. Oh, Zag, I missed you. I missed you, mate. No, I didn't see that. I'm sorry. My apologies. How play Zag theme. yeah, Zag and Garcia are the two most common visitors to the stream. So sorry about that. Nothing was meant by it. I just missed it. Missed it. If you want, the actual city is called Tampere. Okay. But it's sort of like, it's difficult if somebody says right smack bang in the middle of Finland. Finland's pretty long and thin. Ah. Okay. I would see that there's a fairly loose interpretation then to the right in the middle of Finland. What's the weather like up there? So Micon, that's... See, to this time we seem to have a different kind of fault line suggested. Like this. I mean, we've had this one. And now we've got this one. Okay. Oh, cool. It's like small... Yeah, nobody lives up north. I can understand that, because I imagine it's a bit cold. So what's going to happen here is that when the thing jumps, it's going to be like that. But I could go a bit fancy, and no, that's fine. That's fine. Now, when up like that, I probably don't actually want it to animate. I think that would be too much. So what I'm going to do is not have it animate. But we need to have a kind of a transition character for the jump, because I think I want to get a bit more sort of, you know, production values are important. So what I'm going to do, this is pushing the budget of the project up, admittedly. Oh, and I also need to get the 23 is that one. I need to have a kind of intermediate stage. So you've got this one with the legs like that. Now, how do I? It just pops up. But can I be a bit smarter than that? Oh, if I remove the legs, so yes, if I do this first, that's quite nice. Oh, why did that not work? What? Copy, paste, and paste. Thank you. So the first step of the animation is to remove the leg. Then it makes it look like the leg's been pulled up and then it comes back down again, you see. So I'm going to try this. It's a 2-stage animation from this to this to this to back. This particular one is going to be 6-3. Really windy. You know what I miss? I miss a fire. I miss warming myself by a fire. The reason I do that is usually one of the activities that I like doing when I go visiting my parents in the winter in Italy, and of course I haven't been there this winter. First time in a long time, didn't visit for Christmas. So now I'm trying to think about how I can write this animation code for a jump in a way that is really compact, because I don't have a lot of memory to play with. Oh, my clock has gone dim because it's not plugged in. Weird. Maybe I can just put this in like this for now while it's still alive. There we are. I can't find its pop-up one. Have I implemented microtransactions? Well, to be honest, yes, I have implemented microtransactions because this thing is so tiny that any transaction that I have is micro. So yes, so micro. I haven't implemented loot boxes yet. I will have to, because I'm doing AAA 8-bit development here. So how can I implement this jump efficiently? What I want to do is to have a mode where the player is jumping. Well, it means I need to have a state of the player. I need a state variable. Let's start there. I come back and look at my variables. So I have these: frame counter, 2 bytes, player character, jump timer, input 25, player state. So with the player state, you know, that's what I have to do with the player state. And so how am I going to implement this player state? Oh, well, I could have a series of if statements. Why don't I use a computed goto? Yes, because I'm using an 8-bit processor. You know, so primitive. I can do something I can't do in C. You gotta love it. How can I do a compute? I don't know if I've ever done a computed goto in 6502. I must have done. But we're going to do a little bit of studying of the 6502 instruction set. What have I got to play with? Because to do a computed goto, oh, I could just do self-modifying code. You should never do self-modifying code. You should never do a goto. You should never do things like that. Very bad. The universe could split open. No, the thing is with this is it's such a simple process. Some self-modifying code. Who the hell cares? You want to do a computed goto? You have the jump instruction, and you can just write the damn address after the opcode for jump. Boom! Can I change the colour of the characters? What, on the map? I think I can, if you mean the map. I can. Oh, you mean that? If you tell me your colours, like, I'll make it up to Zag by making his favourite colour, because he likes purple. So there he is. Yeah, skin's colour on the game. I did experiment yesterday with like a dim red, and I suppose if you make red dim enough, you can theoretically get brown. So we've got a range from brown, or basically dark brown, brown, dark red, and red. Those would be the choices that that you would get. is, he's running. Look. What about sound effects? Well, that's a problem. I would need to rig up a mic. I would need to rig up some electronics to make sound effects on this. But it could be done. Oh, the things we can do together, you and me, Acorn, System 1. The stuff of dreams. The stuff of streams. What am I doing? That's always a good question. I was talking about making code that jumps. But what I really want is a table. Because although I can make self-modifying code... Oh. I don't know if there is a computed... An indirect jump indirect. That's what I want. There is a jump indirect. Of course there is. It's 6C. It takes 5 cycles. It takes 3 bytes. Oh, boom, boom, boom. The problem is that I need an indexed indirect. Or indirect indexed, one of the two, jump. We don't have that. The only jump that you get is an absolute jump, or jump to the address stored at an address. But I might as well make self-modifying code then. Each instruction, right, wow. So I'm just working it out. Well, nobody really knows what the colour brown is. I thought brown was a dark red, not even a yellow. Because if you make red dark enough, it just looks like brown. But yeah, you're right. You can also have a brown that's an orange. So really, I think as the darker the brown, the less the green component matters. We're getting very technical here. Colour of brown. That's interesting. It's changing by itself. Why is it doing that? I think Hal thought I'd said something and then sent some instructions to this that caused it to switch into Well, maybe it's different for different people, but for me, definitely, if I just make red dark, it looks like a brown. But it's actually an optical illusion. The light, I'll explain the science of it. No, it's a theory. Thinking about it, if you're observing something that's red and you make it darker, you get more of the ambient light on, which mixes in with what you're seeing. The eyes are sensitive to green light more than any other kind of light. Therefore, I think the reason that you can see brown when it's just a dark red is it's that dark red is mixing in with small amounts of green which your eyes are sensitive to, and so it looks like brown. So if I'm correct, and I am correct, because if you take an LED, a red LED, and you dim it, it doesn't look like brown. It looks like a dark red, or a not very bright red, but it doesn't look like brown. So that's what I think the theory is. So what do you think? Meanwhile, I need to do what I want to do is handle my state machine. I want a switch statement, right? In effect, a switch according to a state variable. The state variable could be 0, 1, 2, 3. And for each one, I need to have a destination address. For good flexibility, I need to be able to jump anywhere. So I could use a absolute address. I need a table of addresses. I need to access the table of addresses but I don't want to jump. I really need to do a jump to subroutine. So where's JSR? It's not listed. Seriously. It's missing. In the description they have of this, I never noticed that. Jump to subroutine. JSR is missing. It'll be in here though. 2.0. What? Huh? It's missing. What are you doing? It's a blank. They forgot to put to jump subroutine. So I'm actually going to have to. So at this point, what would you do back then? You go, I don't understand. You get your computing magazines. You would go into the library. You have to go to the library and go, I need to find the 6502 instruction set. There was no internet. You're on your own. That's weird. It's missing. So 6502 JSR indirect. (6502) opcodes. 6502 reference. JSR. The JSR instruction pushes the there is only absolute addressing. Interesting. So I need to have a little think about how I'm going to implement that. As light dims, it gets blue shifted slightly. Oh, I didn't know. So the problem is that the return RTS, no, the jump to subroutine instruction, there isn't an indirect variant of that available. So my options of converting a number to an address, they are, or rather for doing a switch statement, they are a series of if statements, like a series of compares, or I can have a table with the addresses and do self-modifying code. I have a 20 and then I modify the address. That's a bit clumsy though, but it could be done. The other one is to mess around with the stack. I'm gonna see if anybody's, which you couldn't do back then either, switch statement 6502 opcodes. It's like, how? Indirect JSR 6502. Why does 6502 code push usual way to an indirect JSR with a 6502? The 6502 does not support indirect subroutine calls. So it has to be done in software. Making a comment could have been done rather easily. Well, I don't know. They drew out the 6502 design on very large sheets of paper by hand. So easily, I'm not so sure. So it has to be done in software. Indirect subroutine calls. Yeah, that's we'll do it by we'll do it by messing around with the stack, which is fun. So what's all that about, you might ask? I want to jump to a subroutine indirectly. Where is the thing gone? Oh, there. Here it is. Jump to a subroutine indirectly. So I've got here the player behavior code at 300. And this was the animating between two frames. But that's actually a behavior that depends on the state. So what I want to do is implement the state thing. I'd said already that I wanted the state variable to be 25. So the only problem is knowing, well, where to store the addresses. Well, I could store them here. jump table. I will have a 16-byte jump table, which should be enough. So I put the addresses of where the different routines are going to be in here. And this is going to be a dispatcher that I write. So the thing that's going to happen is it's going to do A5, 25, and this instruction is read player state. So I read the player state. Then I need to multiply the player state by 2, which I can do with a shift left. Here we go. The arithmetic shift left. Can you not do that on the... Seriously, we can't do a shift in the... Oh! There's no rotate available on the accumulator. How weird. Are you serious? See, I forget these things. There is no rotation available or shift available on the accumulator directly. Yes, there is. It was just... Oh, single byte with no address mode. That's why it was put here. Of course there is. There's logical shift. I'll be crazy. Logical shift right A. There should also be probably an arithmetic shift left A, which is OA. So a shift left is going to be the same as multiplying by 2. So that's 0A. Shift left, one instruction. If you want to shift multiple times, you have to use multiple instructions. So the shift left is like times 2, right? Because I need 2 bytes for each address in the jump table. Now I need to look up the 2 bytes in the jump table by using an indirect addressing mode. So load accumulator AX and AY. Right, so the particular load A that I want is BD if I use the X register. So BD is load the accumulator with, but I haven't pushed it into X yet. I need to actually do the tax instruction, which always made me laugh. Tax. There's always tax, which is our good old friendly AA. I remember the AA. Tax, transfer A to X. It's the tax instruction. And then I can do BD, which is the indirect, or given the address F0 02 or O2F0, which is the start of my jump table. O02F0 x. So it actually adds, well, I suppose the better way of expressing that is it takes the number 02F0, it adds x to it, and then reads the contents of the address into the accumulator. From the accumulator, I then need to push it onto the stack. So just to look at that a minute. I need to do I push the high byte first, because I need to get the endianness right. So the high byte goes first. So if that's the case, right, I'm going to increment x, which is, I want to say E8. Is that right? E8? Increment x. Oh, nailed it. E8. So E8 is increment x. Because I need to get the high byte first. Then I do BD. It really makes no difference. I'm overcomplicating it. Right, let's backtrack a moment. I need to just say F1. I have to get the most significant byte first and push that onto the stack. There's the instruction push A onto the stack, PHA, which is 48. So put the instruction 48 in there. Plain text. Thank you. 48 PHA push onto the stack. I need to then get the next address. This is pretty expensive on a 6502. BDF1 0. No, this should have been F1. So that was correct. This was 0. And this should be F1. And then I push that onto the stack. So now what I've done is I faked a return address on the stack by pushing it onto the stack. And just compare notes with this. Yeah, exactly. Then I do an RTS, which looks weird. Cool. This because where can you buy the game, Dino? Why can you buy this game? Well, what you can do is you can buy the game that you will never be able to play. This is the key point here, because the purity in the pure game development, making games that nobody will ever get to play. That is, I think, my new bag, my new thing. I'm almost tempted to extend this to music. Make a song, record the song, finish the song, make the video, and then just delete it. And but I don't think I'm going to be doing that with the music. But with this game, this particular game, this game on this one is going to be a game that you will probably never get to play ever anywhere. And if you want to contribute to a game that you'll never get to play anywhere, I know, Zag, you've contributed enough already, but you can go to anyone else, you can go to my Patreon and buy into the game that you will never be able to play. It's almost the same as Star Citizen, but not quite. Oh, that was a bit below the belt, wasn't it? Yeah, a gut punch there. Next, I'll stream without a camera. What a brilliant idea. I like that. Here. I'm now streaming without a camera. We can do that. I mean, of course, that is always a bit. That could be a bit much. That could be overcooking it as well. We can actually try streaming without a camera and without audio. Now, you've got to admit, you've got to, well, you know, that's the thing. And, we may have had no camera, no audio, but there was still a computer. But you know what? I mean, the thing that you'll never know is whether or not I continue talking when everything went black. It's for me to know and you to wonder. You're reading a book in the woods. Just reading a book in the... Are you reading... All right, you're reading a book in the woods. I originally interpreted that you're reading a book in the woods. It's like... Never mind. You imagine the future streams. Hang on a minute. There we go. Something had gone a bit funny there. That's a bit better. Imagining my future streams, indeed. Of course, there was, you know, the Douglas Adams thing. There was a book in the Douglas Adams, and I think he was, well, actually, A Brief History of Time by Stephen Hawkins was not actually published at that point, but if it had, it might have applied to that book, except well, the publisher didn't do this. But basically, there was a book that was very, very popular. It became a smash hit in the Hitchhiker's Guide to the Galaxy series. It was it's just one of his footnote things. But the thing about this was everybody wanted to buy the book, but very few people actually read it. They really wouldn't get past about the second page or third page, something like that. So later editions of the book were published with all the pages after about the second or third page blank. There's something to be said for minimalism. So this weird thing I'm doing here is I'm reading the player state into the accumulator. I'm shifting it left by 1 bit, which is just a single instruction. I'm then transferring the accumulator, that value that I've got, into the index register, and then reading 02F1 plus that value, which is going to increase by 2 each time because I doubled it. I push the value onto the stack. I read F0, the least significant one. I push that onto the stack, and then I do a return. And so what the return function does is it jumps to what's on the stack. That's how the mechanism works. When you jump to a subroutine, the first thing it does is it pushes onto the stack in transparently the address that needs to jump to when the return statement is hit. So this is an indirect jump. I've created a jump table, and so I can put the addresses in here. This fits into very few bytes, But I'm going to start at 310. At the end, if I really start running out of memory, I will have to move things around. But I'm going to start at 310 for the jump table. And 10:03, and this one is going to be running state. So when I call, oh, funky. Yeah, because I've done that, so it shifts all of this. So this I'll need to move up one, like so. There we go. So I'll call 0300, which I do over here, 0300, it's called there, for the player behavior. And the first thing it will do is it will look at the state of the player state. I need to set the player state somewhere, and I have nowhere to set it, which is unfortunate. So what I'm going to do is create an initialization section. I should have left room. Maybe we'll put the initialization section at D0 here. So this is a good old trick that you would do is you patch it a bit in the same way as malware will patch an executable. I don't have room for the instructions in here. But what I can do is jump, and I'll go 4C, which is the jump instruction, to the address of initialization. Or I could do a JSR. Actually, that makes a lot of sense. 02D0 200020 D002 initialize, but this caused things to shift. I need to take all of this and move it down one line so that then I can put an EA in here. So I'll put a NOP because I replaced 4 bytes with 3. So when I run now, it's going to jump to this address, and then I have a subroutine to initialize the game, and that's just moved as well. So initialize the game, and the initialization I had before was A91F 85OE. This is a standard thing for setting up the operating system so it doesn't block on waiting for key presses. But now I can also do the other initialization, A900 85 the player state. So the player state will be set to 0 at the beginning, and then it will jump back into here and execute this, and then while executing it will call this has moved. It's annoying that this moves. Oh dear. This should be at 300, and what I had here is the animating of I'll put it 10. Oh, need to make sure I don't have any missing bits in there. So the first was at 10, 1, 0, and everything's gone screwy with the addressing. It's unfortunate. As I move things around, it doesn't like it. Hopefully that's fixed that now. Right. This needs to move to here. Ah, yeah, it doesn't like that at all when I do that. So what I'll do is I'll copy and paste it and just delete these. So, oh, and this needs to be here. Yeah, this is really annoying. The spreadsheet is, well, okay, there we are. So this should, when it calls the player code, it should go to here, do the indirection, call for state 0, which is this one, state 0 running. It should just call this and do running. So this is a refactoring to allow for what I need to do. Shouldn't affect the game. Hey, hello, Wag, how are you doing? If you let us know which part of the country which part of the universe you're in, I can give you a little marker as well. Did I put FA instead of EA? Did I? I don't know. Where? Let's have a look. Search for FA. I don't think so. Unless it's some kind of pun connecting Electronic Arts with FIFA. See, EA, FA, Sweet FA, EA. Never mind. At the up top, it looks like it. I don't see FA at the moment. Thanks. You are in Luzern. You are near the Large Hadron Collider, aren't you? So if mankind does manage to make a black hole, an artificial black hole that swallows up the planet, you'll be the first to know. Line 2. I'm beginning to feel foolish now. Wait. I just searched the whole thing. So maybe you could give me a hex address. Oh. 0203. That's EA. Yeah. It's EA. What? What? Hang on. I don't understand what's going on here. But let me put your thing in first. It's near Geneva, isn't it? Lucerne. I'm going to look at it like this. Hallo schön, Switzerland. This is Wangu. Okay, there we are. You're on the map as well. Let's see how this is. You see, it's true. There is a fault line. Look at that. You're on this line. How can we deny it? The stats are there. It looks like... Well, maybe I need to make... Map fling. .com. Yeah, it's... I think you need... It was a pixelization problem. See, it is definitely EA. So I need to program this now. So the problem is there's a lot of changes that I've just done. So let's start off at the beginning. We need to have 20D002. Right, D002, and then I need to go one further with an EA, and 0204 is also EA. Oh, what? EA. Yeah, because I don't want the 850E, but I don't understand how that's already EA. Oh. Seven. Right, so everything has got offset by 2. So what I'm going to have to do is take all of this and copy that and paste it, and then down here, so then we get this. That's better. So start again. 2D D002 EA A2 00 B5109510 E8 E0 07 D0 F7 A900 A5 17620 D0. So this continues. I don't change anything here. So this was just the initialization. So a testable change is once I have that initialization routine set up, just make sure things run. This is in the wrong place again. Oh. I put it in the wrong. Okay, so at 02D0 we need to put A91F A900 8525. This is storing 0 at address 25 to initialize the player state. I am not doing anything else, I don't think, yet. Just need to check where it jumps to for the player behavior was at 0300. And that code exists. I'm going to give it a go. Let's see. Will it crash? Okay, that's all good. No crash. Coming from a parallel world where kids are playing KOR, but there's no possibility for kids to play KOR anymore. They will tell you. They'll tell you how shit the graphics are. You're no fun. Bye. Oh, it's a little inside joke there. Yes, there is. This is why I really recommend game developers everywhere make games and never let anybody ever play them. So, right, so that's refactoring worked. But I'm not actually yet calling so I called the player behavior at O series here, which has shifted again. Oh.
Hello, Dino.
Yes, I know. Hello, Hal. Let me park that there. This has got it got into a pickle. Bear with me a minute as I reorganise my... This is actually still better than writing. Can you imagine writing this with pencil and paper? You end up with a mess. So this is better than... Oh, I just splat over something. Okay, I got that. Oh, this has moved again. I can see how making a hex editor, the user interface, are making a really good editor for writing in machine code. It's actually non-trivial. So I haven't implemented any of this yet. That should be what it is. Oh, compiled. Oh, you're in for a treat, Wagyu. You're in for a treat. I'll show you how this works right now, because I'm recreating what it was like. I'm redoing what it was like to program this thing 40 years ago. The first computer I ever owned was an Acorn System 1, this thing. That's how I started to learn to program. So what we had was a cassette deck, the cassette recorder. You would use that to record the programs and load them. You could save and load from that. So I'm using Audacity for that. Other than that, everything else, and the fact that I'm actually using a spreadsheet instead of pencil and paper, it's the same. So you get to witness the whole process. And this is the thing. This is hitting F7. But yes, this is hitting F7. This is the compile. You could call it. It's not really a compiling. This is not a compiler. This is a machine code. There is no compiler. There is no assembler. But there is a workflow. So here it is. What I have right now is that if I press G, I'm telling it to jump to this address where the program is, and that's running the game written so far, right? So now I need to input what I have on the spreadsheet into the device, and so it goes like this. O2, press M for memory, O2 F0, press the up key, and that currently has 0A in it. I need it to have 10. I type in 10, move to the next address, and type in 03. That's all very straightforward. Now we've done that, and we go to address 0300, and we can see that there is some code in there. Now this is the code that was in state running and has to be moved. So really, I just need to retype it, I think. So what I'm going to do is transfer the code that you can see here, this is what I'm doing, into the device. So we do this with, like in this way, very simple process. That's it, and very, very user-friendly, as you can see. DB F002, and it's a great sort of workflow and technology for ensuring that your software is not bloated. I think that's one thing you can be definitely sure of. 002, we do 48, we push A, and then 60, and so there I have entered in a subroutine like function. Now I can just push forward a little more to get to address 10, or I've got the first one of the states. This is the running state, and I need to type in A2, which is load X with 73, which is the 7-segment display characters for one of the two animating frames of the player. And then having loaded that into the X register, I load into the accumulator the contents of address 20, which is the frame counter that I set up, which is incrementing every frame. Then I do 29, which is the AND operation with the second bit 02. So this will be every 4 frames is going to switch between the two. To do the switch, we need to do a branch if not equal, which is D0, to jump over the instruction that loads the X register with the other frame. Now, by the way, that I'm talking through this way, I know you could say is not part of the workflow. You might think it's not part of the workflow, but I assure you it actually is, because if you want this to run, you have to get very, you have to be very careful, because there's no debugging tools, there's no IDE. There is actually a way of setting breakpoints, believe it or not. Yeah, so pedanticness really pays off. Where am I at? I was in the middle of entering in D002, and notice how I have the addresses written down here so that I can match it up with the display, because commonly you can sort of miss the code out. So I'd say checking is a kind of combination of being very careful and sort of correlating the line that you're at, which is 1C, against what it says on your notes. So there's that. And then the next step is to go back. This is verification, which you asked me about. We go back and we type in the address of what we entered, and we go and look, right, that's 1003, okay, fine. And oh, maybe I can just hit this a few times, save me typing in. And at 0300 we have A5250A AA DB F002 48 DB F0, and I just spotted a problem. Yep, bug. DB F0 should be F1. See, there's verification. Catches a lot of the problems that you could get otherwise. DB F002 48 60. Then I have 3 bytes, which don't matter, and then A273 A520 2902 D002 A267 8622, which is storing in location 22 in 0 page, which is the current character that's been displayed by the the graphics section of the game, which is a few lines, a few bytes up there somewhere, the graphics engine, and then we returned, and this completes the verification. This completes the verification of the program, and so now I'm ready to actually run it. And believe it or not, I have very few crashes. I probably have had fewer crashes working on my Acorn System 1, working on this little tiny game on my Acorn System 1, writing in hex, than I would have if I was working on anything at all in Unity. Unity would crash all the time on me. It's like, plus the fact that it's a, you know, this is how long it takes to reboot. Are you ready? I'm going to show you how long it takes to reboot the Acorn System 1. Ready? Here we go. When I press the button, you can hear it, you can see it. I press the button, there. That is, and it can be faster. It can be faster than that. Because one reason why there was a little bit of a delay is just because I held the button down too long. I mean, you know, we could just go like that, you see. Like, that's pretty flipping fast, is how fast it reboots. So should there actually be a crash, you can get back up and running really fast, unless your crash also wiped memory. But that's another story. How do I remember these codes? So what I would, as you can see, am noting things down, but I'm really commenting the code. If I had to actually just write out the mnemonics all the time, it's just be too slow. You just remember them eventually. They're coming back to me. I used to know all of these like the back of my hand. Well, all of these, most of these. So it got to a point where I could program without referring to the documentation. But I have the documentation here. So there are these tables. So these are the accumulator. This is the accumulator reference. Add with carry, logical and, logical compare, different address modes. Here are the opcodes that you put in. It says how many bytes are required for this. If it's 2, then there's the opcode and then one further byte, for example. Branches. These are the only branches that you have. Branch of carry, branch of carry clear, branch of carry set, branch of equal, branch of minus, branch of not equal, branch of plus, branch of overflow cleared, and branch of overflow set. We have then the implied single byte with no address mode. These are opcodes with only one, you know, that don't have any data. Arithmetic shift left of the accumulator, the break instruction, which simulates an interrupt request, a CLC or clear flag, clear the decimal mode, because you can do decimal arithmetic on the 6502, amazingly. Clear the interrupt disable, clear overflow, decrement X, decrement Y. There are 3 registers on the 6502. There's an A, an X, and a Y. Well, there are some other registers as well, but those are the main ones that you use for doing computations. So you've got decrement X, decrement Y, increment X, increment Y. Logical shift right of shift all the bits right of the in the accumulator. No operation, which does nothing, which is the EA, and that's really good with padding out your memory so that you don't have to keep relocating your code. This is not just because then you have to re-enter it, by the way. There is a thing about writing in assembler, well, not so much in assembler, but writing in machine code, that the addresses of jumps, so for example, a long jump, a 4C instruction, you have to jump to an absolute address, not a relative one, which means that your code becomes not relocatable. You can't just sort of take the code and put it somewhere else. If you put it somewhere else, then you need to have to relocate it. This is normal, and operating systems have code to relocate the code so that it can run anywhere, right? So, but because of that, it means that it's really inconvenient to move your code around. So then what you can do is just pad with EAs so that you've got a little bit of flexibility in your code. That's the no operation. You've got push the accumulator onto the stack, push the processor status onto the stack, pull the accumulator off the stack, pull the processor status, rotate the bits left or right. And the rotate instruction, fascinating, because what that does is, as you can see here, is it takes all the bits and rotates them around in a circle through the carry flag. And it's fascinating how no languages support this directly that I'm aware of. It's like C just rubbed that out. Well, we don't need that. You know why it rubbed it out? Because ultimately the languages were developed by academics. This is my theory. They were mainly, the languages were developed by academics, and assembler programmers were viewed as engineers. So there is a kind of, I think there's a snobbery that came in, because it's certainly for encryption algorithms, and also certain other techniques which are very useful. I will show you on here. If I scroll down, I have a random number generator in here somewhere. Where is it? Here. This is a random number generator. And you'll see it uses the rotate left instruction. So this generates random numbers on 5 bytes, or 40-bit random numbers. 40 bits is the equivalent of, 32 bits is about 4 billion. So if you take 4 billion and you multiply it by 256, you get approximately 1 trillion different possible combinations of 5 bytes. And this thing, what it does is it goes through every single possible combination of those 5 bytes, which is going to take a very long time, and it does it in a pseudo-random nature. It's a pseudo-random number generator. It's a very nice algorithm. I like it. It's the one that came, it was actually part of the Acorn Atom operating system. So I never used it in the Acorn System 1, but the next computer after that was the Acorn Atom, so that's where I made games in assembler on that, and I needed a random number generator. I used the random number generator from here. And it's a lovely, beautiful, elegant little thing. It's implemented in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, about 24 bytes. It's a random number generator in 24 bytes that creates a 40-bit random number. It's not wonderfully random, but it has a lot of character. As I was saying the other day, it really, for games, you don't need to be a perfect random number generator. In fact, I think it's better if it's has some kind of pattern to it. But to implement this in C, and this is an example of one of those things I keep going on about how we lose knowledge and information so easily if we do not respect the roots of the things that we use. We'll end up with things like bloated software and unreliable software, and websites that never get finished because they're trying to embrace. They spend most of their time trying to agree which framework they're going to use. Things like that. So this is a kind of a disease that sets in, and it's set in. It's been there a long time, getting worse and worse, and it continues to get worse and worse. And this is one of those symptoms of it, because this is a beautiful little algorithm, and guess what? If you want to implement it in C, you have to hack this algorithm to pieces, because C doesn't have a roll instruction. So what you have to do is emulate the roll instruction yourself. So because the role is because of the way the role instruction works, recreating this in C is that I've done it and it's really awkward. And you could say, well, in theory, the compiler will just optimize it back. But I wonder whether it does. Role instruction. In fact, the situation is so bad that in C, the C standard actually says that bitwise operations on signed integers are undefined. And why? Because of this, I think, unwise attempt at trying to pretend that the hardware doesn't exist. And that's basically, I think, one of the biggest diseases of modern software engineering is trying to get to a view that hardware doesn't matter. And you'll get that in computer science. Computer science is studied in complete absence of consideration of the hardware in practice. It's like maybe there are some studies that are made about things like cache, cache coherence and stuff like that, but really it's viewed with disdain, because that sounds like engineering. It doesn't sound like science. So anyway, I'm ranting. Can't you embed ASM in C code? Yes, you can. But that, of course, you can. But if you do that, then you're defeating the point of C. So sure, you can try doing that. But I don't know. You can end up fighting the optimizer. I could imagine a code optimization. If there is any assembler code anywhere around here, anything within 5 megabytes of this piece of it, we are not optimizing, because if the programmer can't have faith in the optimizing compiler, then we're just not going to do it. Being facetious, but missed this robustness of old technology that wasn't pondered. Yeah, that's exactly it. Exactly what I've been going on about. Built upon millions of layers of software. Anyway, so there we are. I've given you, and I know you understood this, but I was putting on a bit of a show, about showing the workflow. Where did I get to with this? I'm about to run it, and we're going to see. Sometimes when I press reset, there's a little flaw about the reset button. I think it needs a capacitor on it. But sometimes you press reset and it fails to restart. And then it always like, oh, it's broken. But there we are. 0200. Will it crash? It crashed. I thought it was highly likely it would crash. So now at this point, it's like, okay, let's have a little chat. 02 D002 EA A200 B51095510 EA. I could go and check it all. Well, actually, I already know, because I looked at it. When I was looking at it, it did manage to get to here, which is the display. It's the part where it runs the display system for a few times. I saw there was a bit of a delay before it crashed. So, all right. The interesting thing is, when I'm doing this, it's interesting to see how my debugging techniques that I use now to this day were inspired, a lot of them, by the needs of trying to debug something like this. Or maybe I take what I learned since and now I'm applying it. Who knows which it is. But the problem that we've got right now is it's crashing, and I need to find out where. So a technique that works pretty well is simplification. So you just take stuff out. So if I put EAs 0249 and it doesn't crash, then I know the crash is happening in player behavior. So I'm going to just try that. M0249, that's 200003. So we put in EA, 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 and we try, and it doesn't crash. You'll notice that the character is also not animating. That's because it's not jumping to the player behavior. This is nice. It get back to a point where it's behaving in a sane way. It's like in a safe, solid ground, and then you work from there. Yeah, it was possible to get the documentation to get to bare metal because obviously we were able to do it. To be honest, I don't know how we got hold of the doc. Well, some of them were there were books, so big thick books that had them went into the internals of the hardware. But that's the thing, is that what you had was a book and no internet. And it's like I made Kickoff that way, Kickoff 2 that way, I made Player Manager that way. I didn't have the internet to refer to. I had paper copy of books. I didn't have any logging systems. I did have floppy disks. Didn't even have a disk drive. I had floppy disks. I still managed to get stuff done. I still managed to create that Player Manager game, which is very complicated, and it's like one of these mysteries. It's like we think we're going forward, we're not. We did not go forward. Something went wrong, and that's one of the things I seem to be forever circling around, is understanding where did it go wrong. Where did it go so wrong? It took me 15 months to write Kickoff. But this is a game that I wrote by myself. I was the only programmer on the game, and I designed the game as well. And sure, there were people who helped. Like, for example, Steve Screech. He advised on football, but most of that development time he was not actually sort of there. I'm the one who's doing all the coding and making design decisions, and sometimes comparing notes. But it was my call, it was my game. I was the developer. And and it took me 15 months to get it out on the Atari ST. And a lot of that time was balancing the game. Wasn't even programming it. So my point is that somehow all of the convenience that we've had as the technology has advanced really did not get translated into more effective game development or more effective software development. And I've witnessed this now for decades. It's 40 years I've been programming, and I've been waiting for it to get better. I've been waiting 40 years for things to get better. And the reality is they don't. Not really. We do more, we push more polygons, the graphics are more impressive. But the heart of what we do, it doesn't improve. I don't see that. There are things like, we had the internet came along, right? And so then everybody was looking at making, at some point you're looking at making, doing networking. So then people generate network libraries. I was going to a conference or a show, some trade show, whatever, I remember, and there was someone who was selling network libraries. It's like, yeah, you want to make a game, you want to do the network, we got the code, he'll do it for you. And I was thinking, well, it's not that hard. Admittedly, back then, we're not talking about huge, massive massively multiplayer games. If you want to do that, that's another league. But that didn't really happen then. Back then, it was more a case of, can we do peer-to-peer, or can we sort of do local area network for a LAN party game? It was not rocket science, not really. It wasn't that hard. You just have to go and you can use Windows sockets. Windows sockets are not that hard. But you see, everybody's scared of Windows sockets. Admittedly, it's not the world's most elegant API. But part of the damage that was done there was Microsoft. Because not only were Microsoft they were late to the game as far as the internet goes. But the funny thing is there was a standard for internet communication. It's still there. It's called TCP and UDP protocols, and all the other protocols that effectively, in principle, haven't changed in 50 years, other than IPv6, I guess. But the principles are basically the same, aren't they? You still have your your DHCP servers and your MAC addresses, and so the architecture is so. But anyway, Microsoft were a bit late into the thing, and they also had this WYSI operating system that was built like, like a straw hut, basically, that would get blown away pretty quick if the wind picked up too much. Basically, just an architectural nightmare. When at the same time the architectures of computers in the Unix domain had actually been rather nailed down, and so the internet came out from Unix originally, right? Those types of computers. That's sort of like more of where it didn't come from. Because if it did come from the mess that Microsoft were making, then they wouldn't have been lagging behind, wouldn't they? So they needed to have an internet stack. They made it, they called it WinSock. And it was, of course, not implementing the same standard that was used properly. And even now, it's a bit, well, it's got better now. But I remember back in the Windows 95 days, it was an utter nightmare. And that is the reason, perhaps, why everybody stayed away, at least maybe not in the Unix domain, but everyone stays away from it. And then so suddenly it's like, oh, you want to do networking and use this, use that, use this framework, use this service, you use photon networking, use this thing over here, that over there. It's like, well, has anybody considered just using Windows sockets? So I tell you a secret, Kickoff Revival uses sockets. It's like maybe it has to dance around on the consoles, the system for matchmaking and the security thing, but in principle, that's it. It's not that hard. The same thing goes with web development. Why everybody's using this React stuff? And it's like, has anybody sat down and actually sort of seen if all this tech that we're using to build websites every blooming time is actually needed? So the answer's no, it's not needed. What you need to do is program. We got afraid of programming. There's so much not. It's true. It's true. but there's so much. The internet is a huge factor. I love the Specky. It's manual, taught you everything about BASIC. Then on 16 bits or no man's land. Bought GFA BASIC and compiler. Had it hard to find info. Yeah, you had to really persevere. But if you did persevere, you really understood your stuff. So it's like, I really know my stuff. It's like, this can be difficult to convince people sometimes. They go, look at me, and they say, if they're especially, people who haven't got the same perspective as I do. Not everybody's going to have the same perspective as I do, because I've got this perspective of somebody in common with other people like me. I'm not the only one. But a perspective of someone who's been making software for 40 years. It's going to be a little bit different. But it means that I've been there. It means I've seen it. I started with BASIC. I actually know BASIC. So I know what's wrong with BASIC. I've watched the languages evolved. I understand where the point that global variables are bad came from. And I realised that it's a bit like gotos considered harmful is misleading. But what it did was it's that thing. It's like the old story of the battle, and two nations fighting each other, and they fought each other so long that you don't even remember why they're fighting anymore. They just keep fighting, and it's a bit like that. You just lose. Why was it that global variables were bad? I actually know why global variables are bad. What that actually really means, because I had to go through it when I started with languages that didn't have local variables. And you couldn't even pass arguments in functions. You do that, and then you understand the problem with global variables properly. Not having a local scopes. But then the thing gets bandied around without people properly understanding what it's really about, because they don't have that experience. That experience got lost. The why gets lost. I have to continue my series on the moths of programming, because that's what that's about. It's about how the knowledge in the field goes stale, because ultimately it's disconnected from its roots, That's why I'm doing this. I'm trying to reconnect to the roots. I'm trying to answer a question. It's a really important question. Where did it all go wrong? Because it did. I know there's a lot of denial about it. No, certainly not. No, it didn't go wrong. But I look at it and I think it really went wrong. Surely there's got to be a business case for lean software, like software. People who make software that is robust and flexible and only as complicated as it needs to be. Surely. ASM seem like magic. I really love all those stories about finding amazing tricks to make the hardware do more. The demo scene was amazing at pushing the limits. Yeah, what they do, it's I have nothing but respect for those demo coders. They're the ones that keep the spirit of alive, of what programming really should be. You want to get better performance out of something, hardware. We're in a world where it gets thrown away. Your phone, how many phones get thrown away? This waste of resources is something physical. The physical resources that can never be replaced. But that's easier to sell hardware, isn't it, than to sell better software? It's criminal, in a way. Well, let's say at the very least immoral. that we don't extract everything that we can out of the resources we use. We squander them. We get the computers get faster and faster, except now that's slowing down, right? So now we end up with a crisis because our skills at programming haven't kept up. And now we can't just sort of pretend there isn't a problem by just throwing more hardware at it. You know? So, in fact, I've said this one thing I commonly say is that you when you've had Moore's law like this, you would expect software to become, you know, the power of computing to go up with Moore's law as well. The power of the computers went up with Moore's law, but the actual overall improvement was probably linear when you take into account how we cripple all this hardware with poor software engineering practices. Our hardware has been getting better and better, but our ability to create software has been getting worse and worse. And then at a certain point, Moore's law sort of levels off. But the decline is going to continue. So, at least for a bit, until we address it. And so what you actually get is computers start getting slower. And we're seeing that already. I mean, you know, I mean, it's like my phone. I hate the fact that on my phone I press and there's no response. It's like break the first rule of user interface. You always show you press the button, nothing happens. So you press it again, which means it's absolutely fatal to have a toggle these days, because it's like you press it and it's like, didn't work. You press it again because you think it didn't register your press. And so now it's registered it twice, so you have to wait for it to come on, and then you have to, and then it comes off again. It's like the Pink Panther, you know. It's terrible. It's not just a waste of of resources, but it's also a waste of opportunity. It's the saddest thing. Annoys it. It's so annoying. The question is there a solution? I don't know, and I don't care, actually, if there's a solution. I only seek to understand. Microsoft took that. Well, to be fair, Berkeley sockets is from BSD. Those sockets are called Berkeley sockets, and BSD is Berkeley. The B in BSD is Berkeley. So that's the origin. I've been on IRC forever, and all the MIRC stuff still uses old school socket code. Yeah. It's not hard to do amazing stuff in software, unless you use Python, in which case it's very easy to create the superficial impression. You know, oh man. If you look at the amount of time I lose each year fighting with DevOps issues, the problem is clear. Absolutely. DevOps. Huge thing. I mean, you know, when I was working on Kickoff Revival, I found that I was spending, in the end, 20% of my time, I estimated it, I was actually working on the damn game. The rest of it was all the periphery. It was dealing with Unity and it's crashing and making builds and automating the build process, automated continuous integration, and you know, it got to the point that you know, time spent actually programming, and this is one of the symptoms with Unity actually. I think Unreal is better in my experience so far. But with Unity, you have if you have a studio using Unity for software development, the likelihood is that your programmers spend very little time actually programming and most of their time wrangling Unity. This is the truth. Because this is what I found. And my big regret, it's a big regret that I have, was that I did kick off Revival with Unity. If all those years ago when I started working on Kick-Off Revival I had instead the courage to roll my own engine, I would have ended up with a much better result. But, candidly, I had lost my confidence. I fell into the same trap. So it's not holier than thou. I fell into it as well. I fell into the same trap. The comfort of using some other person's software. You use Unity, you say, oh, it will work on all platforms. No, it won't. Because the hard part of getting the thing to work on all platforms is actually not writing the engine for the platform, it turns out. Because if that was the hard part, then it would be really easy. But in practice, you have to do cross-platform development using an engine such as Unreal or Unity remains a difficult task. So then in that case, what about that benefit? Is it really real? Awkward questions. That is the truth, Wagyu. The problem with bare metal coding is the hardware changes all the time. That is absolutely right. So there is an issue, but I think that the way this has been handled has been woefully inadequate. There are other ways of handling it. You know, what we need is a non-monolithic game engine. The problem is that the business model for companies who make game engines, and there are only two of any note now, because everyone else, they're not even going to bother anymore. That's the other problem. Nobody bothers anymore because now you've got Unity and you've got Unreal. Take your pick about which one. But neither of them really do what we need. What we need is a modular game engine. That was the nugget architectural framework philosophy is what we need. But you know, it's a concept, an idea, and it shall remain theoretical and never actually become a thing because there's no business case for it. You know, everybody's going to run to the standard engine and they just live with it. They live with these monolithic things with central points of failure and bottlenecks galore. And we just have to hope that the makers of these things eventually somehow see the light and give us something. You know, just think about how long it took before in Unity we had nested prefabs. You just wait for the nested prefabs to turn up. You know, the actual irony is that instead of using this booming editor where there's this amazing desire to try and make games without ever needing to write any words down, that insanity, right, is that you can actually architect a game engine to give you much better results if at least internally it works with a wonderful invention. It's a thing that allows you to manage very large amounts of data in a coordinated way. It's even possible to have
many simultaneous accesses to that data. We're great for sort of distributing the workload during a build process or coordinating the builds that people are doing on multiple machines. Can you imagine? I mean, can you imagine working on a level? I can, because this was actually done in by Criterion Renderware Studio before EA killed it. Yes, you could actually have people working on a level at the same time. Like, you have a level, everybody's working in the same level at the same time and moving stuff around and doing what they need to do. And there's no conflict. It's not like, oh, you're working on the file, you have to lock it out. Nobody else can work on this. Two people worked on this. How are we going to merge it? Oh, I tell you what, we're going to put things into prefabs. Yes, we tell you what, instead of having a piece of technology that allows us to manage data in a simultaneous access way, in robust, where we can ensure data integrity and also have the performance to work with it, we are going to deal with it all by hand. Yes, we can even go as far as saying that in C++, we're not going to have all of our functions and method calls and variables and everything else. We're not going to have those in this mythical technology that allows everything to be sort of we're going to have programmers managing it all by hand. Yes. What is this thing? If only there existed something that could coordinate data. Yeah. Oh, hang on. Database. Yes, what we need is a database. The database is a solved problem. Just tell me. This is one of my rants. It's one of my favourites. Tell me why we do not use databases where databases would solve the problem of data. Give me a game engine that manages its assets in a SQL database. Give me that. Please give me that. You know, because I'm so tired of working on a game and finding that the library folder in Unity has gone out of sync again. It's like it's gone out of sync. Something has gone screwy, and the method to resolve this is to delete the library folder and then let it rebuild the library. I mean, this is akin to, you know, from time to time our database sort of crashes and goes out of sync, and then this is the procedure we need to do. We need to drop the database and rebuild it. If you do not believe that we're not progressing, if you're not convinced that we're not progressing in software development, please think about that. Please think about that. We don't even use databases where databases solve the problem. So what we need an engine that does the following. All the big components of a video game engine. You've got the renderer, you've got the physics engine, you've got the asset importers, you've got the asset management system, you've got the scene management system, the scene graph, the scene loading system, and animation system, the shader management system, the audio system. Have I got them all? Even audio split into various parts. You've got the actual thing that actually reproduces the audio, which is actually the easy part, and then you've got the bit that manages the assets. But that's part of asset management. Asset management, a huge part. Asset management, best done with a database. But what you do is all those different components should be interchangeable. They shouldn't need to be in the same code base. They should be compilable as separate executables and able to communicate over a network. It doesn't necessarily mean that in the end they would operate that way. It's only important that they can, because then you can defer the decision about how these different components are actually put together. you can decide, for example, to have a separate executable for the editor versus the renderer. Separate executable for the database. This is not unusual because, in fact, a separate executable for the database is how the internet works. You go to, a cloud application, and you've got all of your horrible layers of whatever in there. It's a mess, okay? But take comfort in that the really important part is the data, and the data is handled in a database that runs in its own process. It's not compiled in to your application. You see, that wouldn't work. So it's actually already done, but not in games. In games, it seems, it's like you're working in Unreal, and you crash your game, and it crashes the editor. So the nugget philosophy is all these components could potentially work over a network. It's a measure of whether or not, it's a kind of a crude measure of whether or not it adheres to the requirements of a nugget framework. The requirement is you should even be able to couple the components together over a network so that they don't even necessarily need to be running on the same machine. And you can imagine that would be great, because you do that and you can just swap, you can upgrade different parts or different components separately. You know, you could take the latest renderer component and just leave everything else the same. The probability that you're going to be able to maintain compatibility in both directions is a lot higher if you're not having to couple everything at compile time. Why aren't we doing this? Answers on a postcard, please. I'm going to read the chat. Hey Paul, how you doing? It's a big rant there, but it's something I just feel so passionately. The database rant. Use a database for data. You know. Alessandro Soshi, hello. You are down here somewhere. I'm going to put you on the map. Oh, I only have one marker left. You're somewhere here, was it? I have no markers left. If I remember, correct me if I'm wrong. Because we have two Alessandros. And Paul has arrived. How are you doing? Mid-rant. Well, good. Data. An open source, you see, Ogre 3D, that suffered from a problem of bloat. Compile times are really huge. The west coast near Naples. Oh, I put you on the east coast. There you are. So unless I actually pay money to MapFling, I've used all of the markers that I can. So congratulations if you got on to the map. Paul, I'm sorry you didn't make it. Almost. You know what I can do? I can fit one more in. You can have my marker. If you tell me where you are, I give you my marker. Because I can tell people where I am, you know. Databases solve the data race issue, and yet they are really global state. Thank you, Mark. Thank you. Thank you. Yes. Hit the nail on the head. Because this was the revelation. This was one of the things that helped me on my journey to Phi. I took various routes with Phi, and it was actually fairly late on that I ended up getting rid of the program counter. Altrincham. I don't know where that is. I'm about to find out. Let's try typing that in. Altrin. Do you know this voice? Who am I talking? We're going to try this. Who is this inspired by? This is because everything, all these silly things I do, they're inspired by something. And there was someone I have in mind when I talk in that way. And if you know who that is, you kudos if you can guess it. Klondaiger. Hello there. So, Altrincham. In the UK, Greater Manchester. But it's always good that you're in the Greater Manchester, not the Lesser Manchester. You might feel inferior, if you were. What a nonsense thing to say. But I've said it anyway. This isn't like anybody. Where are you? Oh, you're here. Altrincham. There we are. And so this is Paul Hammond. Welcome to the party. And speaking of parties, and this isn't anybody either, it's just a silly voice. Klondaiger, how you doing? Oh, I've been going a while tonight. I always feel good when I get a good rant out. Where are you, Klondaiger? I can't, unless I... Oh, Michael left. Michael left, didn't he? He said he left. I have a slot for you if you tell me where you are. I put a marker on there because I like to sort of... Oh, dear, I moved Alessandro. Oh, no. He's in Milan. There are two Alessandros. He's the Milan Alessandro. The guy creating... Yeah, this is... Well, we're always living in the future or living in the past. That's why we're unhappy. What we need to do is live in the now. Southern Germany in Mannheim. Okay. Mannheim. Come on. Let's find Mannheim. Mannheim, Germany. Where? Oh, yeah, there it is. And we can get... There we are. Clang. Clack. Vet. Paste. And so the map now looks like this. So do bear in mind, if you want to get into the map, arrive early in the streams. It looks something like this today. There we go. You see this fault line here? It's like, what is it with this line? I don't know. Fascinating. Right, so chat. I'm having more fun ranting than I am programming, and I have quite a lot of fun programming, so you can imagine. Where were we? Yes. They are like so when the journey to Phi was the realization that the way to solve the architectural problems in software was to look at the internet. And on the internet, resources are all accessed globally. It wouldn't work. Can you imagine an object-orientated internet? It's like, oh, you know, I like to use the site eBay. Wonderful. You know, I'll just, how do I do that? Oh, I need to call an instance of the website access maker. And it's given me my access key reference. It's given me a reference to eBay. I mustn't lose it. I need to keep it somewhere. Then you go to use eBay. Where did I put that? It's a bit like using your bank accounts, actually, funnily enough. It's like, where's my thing? Where did I put it? My thing for accessing my bank account. So, yes, irony is that we actually do have that, but that's usually for security reasons, isn't it? The internet, in principle, doesn't work that way. The way it works is you call things by name. So this inspired the idea of memory allocation by name. Instead of you do a new and you get a reference to your thing, is you make a constructor that doesn't return anything. You just specify a name and it will make the thing, and then next time you want it, you use the name. And as soon as you do that, the whole world opens up, literally. That one change is huge, and guess what? It's an embracement, is that even a word? It's an embracing of global state. So you hit the nail on the head there. I guess you can create async issues and use long transactions. There are problems always that need to be solved, but these have to be solved and are solved in our weird and wonderful different technologies that we have in cloud, cloud technologies that we have. That's the point, is that we don't have to solve them again, and we can be inspired in our software architectures by those bigger architectures if you pay attention and look at the bigger, the architectures of the internet are actually relevant for architecting even code on a small application. At least that's the way I look at it. So exactly what you're saying. The hard problems are solved. There is a problem, of course, that I just knocked something, and so now the camera died. It has a habit of doing that. So let's just try and get it back again. There we are. Yes, software, lovely, reliable stuff. West Coast near Naples. Naples are great. We'll recommend driving through Naples, though. I wouldn't recommend driving in Italy at all, basically. All right, so there we are. I've caught up on the chat. Had a rant. A feel-good rant. What I'm going to do is carry on with my game. So where I got to, can I remember where I am? Yes, funnily enough, is that it was jumping to address 0030. I took that out and it didn't crash anymore. Let me go and fix that 0249. I need to jump to address 0300. If I go to 0300, so the next thing I can do, I'm going to take this a step at a time. There's no point in... Also, the iteration loop here is so fast, I might as well do this. I'm going to replace the A5 that you see there, which is the first instruction at 300. This A5. I'm going to replace it with 60. So now this is a return statement. Immediately, I'm jumping to the function and immediately putting a return statement. A return opcode. I do exactly the same thing when I'm debugging. If I'm unclear, and I'm very pedantic when programming in machine code, because I would expect this to run, and it is running without a problem. So now I know that the call is correct. I didn't mistype it. So then this starts off with A525. Which was load whatever was in the is the player state. I've loaded the player state and then shifted it and then transferred it to the X register. And so this is basically what I'm doing, is an indirect jump. This is very tricky, and it might be that I got something wrong. It's a bit tricky, and I got something wrong maybe. So I need to DB, I need to check that opcode, because the DB opcode should be load accumulator with AX, so with an address to which I add X. So that is the correct opcode, BD. So for F10, there's F102 is this. So this is the least, it's the most significant byte of the address I'm jumping to, and I have to push that onto the stack first, and I get the second address, which is the least significant, and I push that onto the stack, and then I do a return statement. And the comments are all out of phase here. Copy.
Copied. I captain.
Oh, stop that!
Compilation failure.
You woke up, Hal. I am, and you're not. I'm not asking you to do anything yet. Right. So this should be pushing it onto the stack, and then I do RTS. I'm looking at that, and it looks correct. So, but it could be then. Well, I have to be careful because I do a subroutine call to 0300. I push something onto the stack. This RTS will cause a jump to 0310, which should be here. This is unlikely to crash, so it's probably the indirection thing which is not working. So now how can I verify this? Let's check. I'm going to just check the code first of all again. 0300 A525 0A. That should be shift left. Let me check that that's correct. OA. Right, I can look at it in here. OA. Arithmetic shift left A. Right. So this OA multiplies that by 2, but it's 0, so it should remain 0. And then I get O2F1. Yeah, okay, that should work. That AA is transfer A to X. Let's verify that. AA transfer A to X. The DB 48 push A. Yeah, this looks correct. At O2F0, I've got nonsense in there, so that's where the problem is. I think I must have had a brain seizure at that point of some kind. That looks like it's what the issue was. You know, I'm a little concerned about crashes that could corrupt memory, so what I need to do, I just want to back things up, because if it corrupts memory I have to type everything in again. So I'm going to mute that, stop. Have I got recording going? I need to be careful to make sure I don't deafen you. I'll do that again. Right. Alright, let's try it. So I'm going to save memory from 0200 to 0400. 0200 to 0400. Ready? Hit record. Stop. Undo. Add a track. Add a new track. Add a new mono track. Right. On this track, please, we're going to record. Rewind. Yeah. There we go. And hit save. I think it's recording. So the display is blank. The display is blank right now because it's saving, and it never shows anything while it's saving. Hey Zag. One sec. Okay, and it's finished. And then hopefully it looks like, let's check we have data. Yeah, we've got data. So what I'm going to try to do is, just for my comfort, make sure that I can, no, I'm not going to test it because there's a risk if I test it they end up corrupting unnecessarily. I've saved the project. Right, what was that? Zag, I put you sort of here in Texas. Just in the middle. So if you want your pin moved, you let me know. I'm going to have to go get a drink in a minute. So I've saved that. And I'm going to try running it. Reset. Right, 0200. And it crashed. So let's go have a look at 02F0. OF02. That is actually the wrong address. It's F002. Okay, let's try again. It still crashes. Let's go check that memory. It's corrupted the memory. You see, that's what happened there. It's actually corrupted that memory. Which is kind of interesting that it would do that. That would suggest that this is a store. Maybe there's a problem with the opcodes. Display goes blank when it crashes because the CPU has to continue running for the display to run. It sometimes will just hard turn on one of the digits and sometimes jam on and it crashes. No, it says load accumulator is BD. And store is 9D. So that's really odd that crash. So now they've got an interesting question. How do I debug this? Read the player state, blah, 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 and all this blah. I was looking at an article here that showed, according to this article, you push the high byte So this is where we go. We push, and this. All right. What do I have in the address 25? Why does it change it? No, that's the weird thing. $10.03. Did it really change it, or was it just me having another?
02F03. Yeah, it changed it.
020F. Okay, what I'm going to do to debug this then is change the instruction at 0300 to an RTS, which, there we go. This should not crash. Right, okay, it does not crash. That's good. I'm going to check 02F0's memory and put it back to what I want, which was 1003. Then I run, and it's running, it doesn't crash, and then I check the memory. Alright. So I know that nothing is corrupting the memory other than this bit of code, which is very suspicious that this should modify the memory. It's almost as if this is a store instruction instead of a load. So it could be that there's a problem in the manual. 6502 opcodes. I need to, because I can't see how could it be. So if we look at, say, BD in this thing, it's load accumulator. It's 3 bytes. So that's interesting. BD. Everything I look at seems to be correct there. I'm not seeing any problems there. So let's have a look at what's in address 25. 0. We shift arithmetic shift left. We transfer A to X. I think the only well, it's not making any sense. So I think the thing to do then is the old classic, will move the return, which I have there at, you know, it's covering what was an A5. A525, I can't change anything. Up to the DB, right? And then run that, should not crash, that's correct. Then we can check the address 02F0, 1003. Did I check what was that address? 100310 A273 A520 2902 D002 A267862260. That looks correct. There isn't much that can go wrong with that. So crash, which is great, so that's fine. So then we do the first DB. F1 02, and then it did the push A, but I'm going to put return there. If I go now, yeah, it doesn't crash because it shouldn't. I don't know why it would crash. 02F0 has modified. It's like that is. I'm sorry, but that's saying that DB stored to the accumulator. That is perverse. I put a 60 return here, so let's load the accumulator, mess with the accumulator, transfer the accumulator to X, load the accumulator. This is modifying address F102. 02F1. You can see there, modified. Wasn't what it was. This means that DB is acting as a save. How perverse. So where am I? What am I? Where am I getting this from? How many times do I have to look at this? Oh. One moment. Oh. Oh. Oh my God. I'm not doing BD. I'm doing DB. I got it. What is... Oh, lovely. I got them reversed. You see, maybe there's a little touch of dyslexia. DB. Because the funny thing is, the D and the B's are mirror images to each other, but only in lowercase. How strange. Why not? I didn't spot that. So let's have a look. DB. Tom tom tom. DB is not a valid opcode. But the funny thing about the 6502 is that there are opcodes which are not supposed to be used, but something happens anyway. Rather than putting in the electronic circuitry to make the 6502 stop when an invalid opcode is executed, it just runs the thing anyway. Oh, my camera stopped. It just runs the things. It runs it anyway, and so there are unofficial opcodes as a result that have been known to be used as hacks, performance hacks. It's not a good idea to use those. My camera has died. Deactivate. Activate. No. So what I'm going to have to do is deactivate that, and then I need to unplug it and plug it back in. So is that fascinating? So this invalid opcode was writing memory. That'd be an interesting project to map out the unofficial opcodes of the 6502. There we go. So right, let's fix that. Silly mistake. BD, not DB. And we'll just have to edit that here as well. So we go put in there 1003, and I need to go to a memory location 0304 where I put BD, and then 48 and BD. That's the one. And it still crashes. Grrr. Memory location 02F0. Just check in there. We have 1003. Oh, 300. We have A5 25 0A AA BD F102 48 BD F002 4860, and then at address 310 we have A273 A5229 D02 A267 862260. So rather than messing around too much, I'm going to put a return statement on 0310. It crashed. It's not surprising. I wasn't expecting that really, but it's worth a check. A2. Check this code again. A525 0AAA BDF102 48 BDF002 4860. Assumption I'm going to make is that the website that I looked at, person got it wrong, has these two things the wrong way around. I'm going to try to change that to F0 and that to F1. I can't think of anything else. Let's try it. Yes. Let's compare notes. You've got, that's the problem with the internet. He's pushing the high byte. He's pushing the pointer +1 first. So that is the most significant byte first and the least significant byte second. Nobody has pointed this out that this is wrong. No. Wait a minute. My bad. I didn't read all of the. Always keep in mind to use target address -1. I didn't read that, did I? And it could be that swapping the two just happens. Alright, so let's follow the instructions properly then. If I put this back, it's always good to check, double check, triple check. 8250AAA BD F1 02 48 BD F002 4860, but I have to write the target address -1, so that would be OF here. So I need OF03 . Yeah. There we go. So that was the funny thing, you see, because I swapped them. I thought, hey, it must be wrong. I swapped it and it ran. But in fact, it was La La Land. That post was correct. I have no idea why it ran. If I flipped it the other way around, it was just luck. So there we are, and you can see that the player character is now animating. So what I have now got is a jump table, so that I can jump to different code depending on the state of the player. Good stuff. So I need to take a break, get some water, and put the map back. There we go. There's our map. And cool. And let's have well, God and the River. That was released 3 weeks ago. Available on whatever. Back in a minute.
In the beginning was the Word. And the Word was walking along and by the stream searching. I felt like a 2-year-old urchin. Was thinking about the sun somewhere behind the clouds. And the trees, they all agreed with that chattering sound. I went for the stars, but I could not see any, nor the sky above, nor eternity. There were no words to spoil or taint the scene. No black, no white, no grey, nothing to be. So tell me, did he really know what he was making? And does he already know the ending? If God had a river of his own, did he learn to let go? Let it carry him down to where he needed to go. Was there anyone looking after the place here he would be? Thereafter I want to know about God and the river. Makes no sense, there can be no pretense. If you look at us, we're all like little children playing in the playground, but not so nicely. If God is our parent, then where the hell is he or she? Tell me, did she really know what she was making? And does she already know the ending?
obviously that forces us now to fade it out by then.
So, let's see if we can get a bit further. So I've got now a state machine. And
Build your multiple with Betfair. Get a £5 free
Hang on.
bet when you place
What's that?
£20 worth of football multiples.
that was a bit too exciting at this time of the night. What I want it to do is to I need a state which is animating the thing. Let's do that here. So this is state 1 is going to be jumping. And so, how will I implement that? You see, the interesting thing is that even though this is such a simple game, such a simple bit of programming, I still have to face the same problems. You know, it's like I could do with the coroutines. Oh, why didn't I implement coroutines? Oh, why did I not think of that? I don't need a state machine if I use a coroutine. Oh, that's just so nice. Of course. I'm actually going to change this and use coroutines instead. Because you see, the thing is that if I'm doing the jumpings, you see, the problem is that I need to do things. I've got two things going on all the time. One of them is the gameplay, and the other one is the display. So if I have a delay in my jump, I mean, you know, the thing is on the ground and then it goes into the air and then it comes back down. I have to wait for those things, don't I? Can I really just use... I can do it this way. It can be, because we can do it this way. But if you use a coroutine, it's just so much easier. So the only difference between what I've done here and when I use a coroutine is that I'm using a state variable when I can actually just use the execution address instead. Oh, there's so many clever things that could be done. I don't have a macro assembler, right? It's worth having a go, actually. So what I can do is use a bit of memory somewhere to do an experiment. Say I've got nothing at the moment at 0330. What I want is to be able to create some instructions that it will do a return statement 60, but before it does the return statement, it puts the address of the instruction into a memory location somewhere, so that next time I can jump to the first instruction after the RTS. Now, if I do a jump to subroutine, if I want to get the program counter, this is not necessarily the fastest way to do this, but that speed's not really the issue here. Bytes some of the issues. I mean, you could say this is not, I don't know how efficient this is going to be, but if I want to get the program counter, there's only one way of doing it. So that's the first exercise, get the program counter. My way to do that, I'll just check on the instruction set, because I really don't think there is any way. No, there is. I don't really know. There's no way to get the program counter directly. But what I can do is jump to 20 subroutine. So the 20, jump to subroutine at 3303. So literally, I'm going to jump to the next instruction. This seems a bit weird. It's like, why would I be jumping to the next instruction since we'll be getting there anyway? Well, it means that I get here, but now the address of this instruction is on the stack. But the thing is that since I have to specify where I'm jumping to, there is no relative branch to subroutine. It's getting cold in here. Oh, I don't need that to turn. I can just ask Hal. Hal, please turn heater on.
Turning heater off.
No, I want it on. Hal, turn heater on, please.
Turning heater on.
Thank you. I forgot I can ask Hal. Oh 023303. Coroutines. I mean, if I have to specify the address manually, I don't need to really do all of that nonsense, do I? Except there is no way to handle a 16-bit address directly, because there are no 16-bit registers. But I can call a subroutine and that will give me the address. Oh, right, yes, okay. So what I could do is have, say, 0340 here. I create a subroutine. When it's called, I can get blah blah blah. I need to get Oh, it's on the stack. Can I get the address of the stack pointer? If I can get the address of the stack pointer, then what I can do is, when I call a function, that function has the address that it was called from. It's on the stack. And maybe I can use that. So... blah 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 blah. RTS, return from subroutine, transfer, stack to X. TSX. TSX transfers the stack pointer to X. So I could do that first. TSX is BA. So if I do BA here, then the stack pointer is now transferred to X. I can then read the address on the stack directly by using the load accumulator index 0 page instruction. This is here, load accumulator 0x, it's B5. So B5, oh no, not 0 page, because I can't read 0 page because the stack's on page 1, not page 0. So what I need is load X. I use the BD instruction. So BD 01 0001. So let's make some notes. T transfer stack to X. Get address. Well, actually, the stack pointer is going to be pointing not at the address is going to be above that. So if I actually do 01, 1 and 02, it's like if I had the address at FFE, FE, the stack pointer would be at FD. If I add 1 to it, I get FE, FF. So we know from pushing it pushes the most significant first. So as I read it off, it's the least significant first. So I actually need to put 0101 in here. This is the address, the LSB, the least significant byte. And then I can save it somewhere. So what I would need is to have a couple of bytes to save the address. So for example, we could do 26 and 27 proc address, no, coroutine. Address player for the player. And this is, I could probably keep it all in a page and save a byte, but I mean, I'm not going to worry about that right now. The coroutine address for the player. So yes, I'm going to make coroutines in 6502. We're going to go and, oh, what was the address again? I've forgotten already. 26 and 27. So then I need to store it in 0 page 26. Store it, the LSB, and then I can just get the second address, BD0201, 0201, and that's get address MSB, and then I'm going to save that in 27. So this is done. Is it saves the return address. So this is the address following that. Now actually I need to add 1 to that address. I mean, what's going to happen if I jump to that address is it's going to jump onto the return statement, because the idea is save the address, return. The address I need it to jump to needs to be one more to jump over the, to skip the RTS, that's the 60 code. So I need to add 1. But the problem is adding 1 is a 2-byte value. I could make it a rule, but you can't. It has to be within a page. That's actually probably not a bad rule. I could say, you know what, let's make it so that you can't have a coroutine go across a page boundary. No, I don't like that idea. It feels like it's going to be a pain. Although really I've only got 2 pages to work with. So. I think it's fine actually. It's not like I've got a huge amount of memory to work with, right? So coroutines are going to be forced to have to work within a page. I've only got 2 pages anyway, so I suppose I could use stack memory as well. If I really want to extend it, I just make another coroutine variable. That, you know, I think what I'm going to do is just have 1 byte coroutine address. It just simplifies the code. So 26 is that. So right, my new idea for the coroutine. Now if I want to get the least significant byte, that's the first one. I get that and I store it, and that's it. Now oh, that was
that could work quite nicely. That's really. Calling 0340 is going to. It will save the return address somewhere, and it returns. That's it. So calling that will simply put the least significant byte of the return address into the coroutine variable. I need another function which will then do will call yeah, that will do the other part of this, which is something. It's also pretty stupidly simple, probably. When I call this function, what I need to do is when I return from this function, I need it to return to the address that was stored. Now, because I'm actually saying that it all needs to stay in the same page, the call to this function needs to be in the same page of where it's going back to. So I only need, that can just be the same. The most significant byte of the return address can stay the same. The least significant byte is substituted for the one that was saved, +1. Oh, this is really stupidly simple. Wonderful. Alright, I'm just going to add it right here. So the plan is, when I jump to this, I've got to A5 to load the address that was stored into the accumulator, and then I need to push it onto the stack to replace the least significant byte of the return address, which is available there. I can pull it off with PLA. In fact, actually, this is easier. Oh, this is quite nice. I can do a pull A. This is fun. PLA. Let's pull A off the stack. So, and sorry, its thing PLA is 6.8. So if I use the instruction 6.8, I'm pulling a byte off the stack. I've now pulled the least significant byte of the return address off the stack. I'm not actually going to use that though. It's just really doing that to move the stack pointer. I do A5, which is read into the accumulator from 0 page at address 26, which is the continue address, and then do a push A. Now push A was PHA is 48. So what I've done is a little bait and switch. But what I need to do is increment A. Right. Must remember to increment A. Do I have an increment A instruction? Surely there's an increment A instruction, isn't there? Maybe there isn't. No, there's no increment A. There's only so I can do this by transferring it to an index register, doing an increment and transfer it back. That's 3 instructions. I could also do it by adding one, but this involves the add instruction on the 6502 doesn't have an add without carry, so I would also have to clear the carry flag to make sure.
that worked. That would be also 3 bytes. But I guess I can do this. There is an instruction to load the X register from 0 page A6. So instead of loading it into that's probably the best one. Load it into X. Then increment X. Which is E8. Then transfer X to A, 8A, then push A for 8. Transfer X to A and then push A. So this function is pull A off the stack, then read the continue address that was saved in 26 onto the X register, then increment the X register. So this incremented the X register, so it's the address plus 1, and then transfer that X value into the accumulator and push, and then RTS. This kind of trick you can't really do in C either. So what's happening now is that I have basically in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13 bytes I've implemented a very simple coroutine system. It's like the first method what I call will save the address. That then I can call the second one to go back to where I left off. So I wonder, how can I do that? How can I test that? That's the question. It's like, how do I test it? Let's try putting some code here for testing. I can actually test this by just jumping to this address, running the program at that address more than once. And I'd run it twice. The first time it will execute one piece of code, the second time it will execute another piece of code. Alright, that works. A9. No, I don't need to set... oh, yeah, I tell you what, just to know A9 00, I need some 85 FF. I'm just using for debugging, so I'll read the address FF in 0 page to see what happened. The first time that this is called, oh, okay, yeah. So then I'll do 20 4003. So I'm basically calling this function here, or maybe I should give this a name, which is going to be then do is the idea. So this is calling then do. That just stores the address. I put a return. So I'm going to jump in here and put 0 in address FF, and then I call this very simple function up here, just this from here to here, this. I call that, and this will save the address, the return address, in variable 26 in the 0 page. The problem is how to because when I call this again, I need to put in the jump. So where does it do the jump? Because there's an initial, yeah, I have to initialize the thing. So the initial, yeah, I'm just thinking about for testing the initialization of the program counter for the coroutine, right? It needs to be initialized. So I suppose that's what I should do here first of all then. What do I put in 2.6 initially? Okay, what I could do is the following. Right, okay. I'm going to write 0 into address FF and call this and then do an EA, a NOP. The reason being that I just want it to pass through. Is that? No, I don't know what I'm talking about. It's when it jumps back. It's going to jump back to here. I think what I'm going to have to do is manually set the address. I can't really, because I need to actually call this other one. I'll just call it exec. So it continues. Oh, continue execution. That's what to call these. Continue execution, but I need to prime it in order that this continue execution works. And it was how to do that. We need to point at it. So I'm going to. That's a bit awkward. I don't know if there's any way around that. This one is on the thing like that. have to point it somewhere. It's not. I have to initialize it somehow. I can't really see a way around that. No. Yeah. There's no way around that. So whatever this address is, which I'll find out in a minute, I need to take that and then I need to initialize my 085. I need to initialize my variable at 26. And then the program actually starts. This is the initialization. Then the program starts here, 0358. And I do a 20 4803. 24803, that's jumping to here, where it's going to pull that address that I just stored off and then put it in, so the return statement jumps us into the right place. It adds 1. Okay. So it never gets to this instruction directly, but will the first time, because this is going to be FB. It probably needs to be -1. Think about this. Right, because this always adds 1 to the address, why will become clear in a minute, we need to put the address, which would be here, because I want this to jump to here, but I'm going to have to subtract 1 from the address because it adds 1. So this address would be 0359. 59, I should say. No, 5A. Right. So what I do is I load the address in front of where the execution should be, this 5A. It will then add 1 and start executing at 5B. It stores that in there. It then executes this function, which should pull that off and cause it to return back to here. So in fact nothing really would happen in principle, as if it wasn't there. But then I take the value A1 and then I store it in FF. So store 0 in FF, initialize the jump to 5A, so it starts here at 5B, 1 address further, in 26. This actually causes it to jump to 5A plus 1, which is here. This stores 1 in FF. Okay. And then, this is what I've been working towards here, is to do this 204803, so this is branch 2, subroutine, this subroutine again, 60. And this will cause it to remember this address, return. The next time I come back into here, it will skip this instruction and come back straight down into here. So what it's like a virtual program counter. If I put it here, 02 85 FF, and then we can do it again. And then 60 A903 85 FF, and just keep it there. Well, actual fact, what I could do is, why not? I'll use a different instruction, which is going to be the increment. Oh, great. Read, modify, write instruction, but increment a 0-page address, which is E6. Oh, where are you? There, E6. So on this one, it's going to do E6 FF, which will just increment FF return. So what this is two subroutines to implement coroutines stored with the virtual program counter stored at address 26. Set our debug variable to 0. Set the starting execution address to 5A plus 1. So that's here. Actually do that. This is the entry point. And this is the initialization point. And yeah, let me. What I'm going to do, I'm going to change this a little bit. Full C 04 FF. This is jump to monitor. This is all the operating system. So for testing purposes, I'll execute 0350, which will initialize the system. Then this is the execution point for my coroutine. Which does but then in order to do the testing of the operating system. Oh yeah, okay, that's fine, I think. Yeah, because when I do that jump, I still need to do an RTS. I can't do an RTS. Can I do an RTS on the monitor call? I've got to check that actually. I think it's normally you do OC04FF to jump back to the monitor. 03, whoa. 02F1, what did I modify? 02F1. OF03. Okay, modifying something I didn't mean to modify. 03F0. I don't think I have anything there. You have to keep track of all your memory. 03F0. Oh, I do. I've got the 03. I've got the random number generator there. 0380 looks clear for a minute. 0380. If I just put an RTS
instruction at 0380 and then try to go to 0380, it gets very confused. So no, I can't really do an RTS instruction safely. But these require that there is an RTS. So we'll need to do a jump to subroutine at some address and then 4C CO4FF. Let me put the question marks in here. Well, that, oh, well, actually, it's just 6103. So this jump to the subroutine that's here and then return back to the monitor. So this is actually this is the test rig, if you will. This is actually the exec, or we'll call it test exec. So I guess that's a unit test thing. This is the actual exec function. Right, when we call that, we need to do a 20 4803. So 24803, which is here, and what this will do is jump to the appropriate address, which has changed. So I'll have to fix that because I put stuff in. This was the this is the code. So we do the exec. This is the number 1 execution point. This is then do number 2, then do number 3, and then in this case always, because this is a true coroutine, slightly different from what Unity calls coroutines, for example. It's more like the original coroutines in the Conway paper. So this should actually be a testable coroutine rig. A9, so recapping, A900, load the accumulator with 00, store it in address FF, and load A5A, this should be the address -1 of the first thing to execute, and that would be at address 63. So I need to change that. It's now 63 because I inserted some code. So we're going to start our execution at address 63 + 1. That's 64. Jump back to the monitor. This is a test rig. So I would go to 0350 and run here, and it will just return immediately. But I would have set up A9 to have 0 in it. Sorry, FF to have 0 in it, and 26 will have 63 in it. 63 being where we're starting the execution of the coroutine. Then next stage of the test is I go and execute address 035B. This causes it to jump to subroutine at 0361. Which calls the subroutine at 0348, which pulls the address that I stored 63, swaps it into the return address of the thing. When the RTS instruction of this call is called, it actually will jump from where it was, a bit like a long jump. From where it was, it will jump somewhere else
In fact, where it will jump to is 64 here, where it will store 1 in the address FF debug value, because I've got no logging, so that's debug by storing it in a value, and then I can check in the monitor if the value changed. Are you following me? Then we call this then do instruction. This is calling the wrong one. 03, it's a good thing I checked it, 0340. Call this one, right. So what this does is it takes the address of the RTS instruction and saves it in address 26, and then it returns. When it returns, it will return back to the test exec to 4CO4FF, returns back to the monitor. So if I do that, the first time I exec, I should get 1 in address FF. Then I execute again, and this time it will have remembered this address. It will skip this and come in and do number 2 and store 2 in address FF. That's the coroutine. And then after having set 2 in address FF, it will say, look, next time continue from 3, right? Or then do continue. It will do an RTS, which will then return back to the monitor, and then I can execute again. This time it'll jump straight to this instruction, which increments FF, and every time after that I am executing this function, this subroutine, it should be incrementing FF. So that would be, obviously it's stackless, but that is a coroutine. You can't do that in C. I'm quite excited implementing coroutines on an Acorn System 1. Let's type it in. A9 0085 FF A9 63 85 26 4C 04 FF 26103 A901. The addresses are all wrong. That's somewhere 035E. Let's go back. Lost my place. A90085FF A9638526 4C04FF 26103 4C04FF 24803 24803 A9 load accumulator immediate 085 store in 0 page the accumulator at address FF. Execute the subroutine to address 0340. So then do. We're now at 6B. Yeah, something's gone wrong. Out of phase again. Might be due to screwing up this thing here. Let's see. Yes. Okay. According to this, I should be at 6A. Where's 6A? No, something is still screwed up. Let's go back. A90085FF A9638526 4CO4FF 206103 0361 Yes, that's the test exec thing.
That's right. 4C04FF 24803.
A90185FF, store 1, address FF.
200403.
Jump to then do 60 at 6B.
There we go.
A902. 85
FF.
That's store 2 and address FF, and then we call then do 204803, and then
Return statement.
and then
E6 which is increment, 0 page memory FF, and then return.
will it work?
That's the big question here.
This would be amazing.
This will make me feel so good.
In ways I can maybe only I can understand. 0350.
Nothing happened, which is correct, as it should be. I need to check the memory location 0026.
This has the address 63 in it. It was just wired in here, so that's all fine. This didn't do very much.
We checked the address 00FF
And it has 00 in it. So far the test is fine. We now start executing from address 035B.
So go 035B. This is probably going to crash.
I'd be very surprised if it didn't crash. Well, it didn't crash. Oh my god, I didn't implement this first time. No, that's just... See, this is the weird thing, isn't it? It's like I'm... What I am learning is that when you have to be really careful, because your situation, your programming environment is inconvenient, the result is you take greater care over your work. Memory location. I said that, and it didn't crash, which is great, but it also didn't work. Huh. It should.
So I have a bug. It didn't crash. It's doesn't seem to be. It's not, my debug variable is not actually incrementing. You know what, Scott? Thank you. You know what? The thing is that I know that people watch me do this stuff and they say, I don't understand what's going on. So don't underestimate the ability for your subconscious to piece it together. We all think that thinking is something that has to be done consciously, but our brains are marvellous things where most of what happens up here we're not aware of, and so you never know when you see anything, when anybody says anything, when anything you observe or you experience, it's meaningful. If you enjoy something, even if you don't understand it, the fact that you're enjoying it means that you do understand it at a certain level. It has to. And you take something from it. And this was something... I know I was talking about learning musical instruments. If you play musical instruments, you watch someone play a musical instrument. And it's actually better if you can watch it in person.
and you go, oh, how did they do that? There's a part of your brain that's figuring that out. And you learn, you pick it up. You know? In other words, it doesn't matter if you don't understand. What does it matter? Some part of you does. That's true with everything, I think. But what I'm having here as a problem, you see, it's not, that variable is not modifying. But, well, there is a way I can check this, because I can check what the execution address is. That's what's stored in 2.6. Because that should modify each time. And it's still 6.3. So basically what we're looking at is that it never changed. Now, what would cause it to change? This would be the function here at 0340. This should store something at 2.6. I'm just going to check that. 0340 is like, yeah, the wrong code. Well, that would explain something. Look, 0340 should be BA. Maybe I never entered this in. British Airways. British... BD for British Airways, British Delusion. 0101. I forgot to enter in a piece of code. Obviously what's there is harmless. 8526 60. I didn't enter any of them. That's how it didn't crash. I don't know. A626 E8 A8A 48 60. So now, having actually put the functions put in the code here that already wasn't even in there, it's probably now going to crash. Let's have to rerun my tests, starting from the beginning of the test entry point, 0350, execute. Okay, now we need to repeatedly execute 035B. So go to 035B, and it crashed. Which is, in a way, a bit comforting, because there was no way that this was going to work first time. So now protocol 0340, check the bytes BABD 0101 8526 6068 A626 E8A 4860 to whatever bytes, and then A90085 FF A963 8526 4CO4 FF 206103 4CO4 FF 204803 A90185 FF 200403 60. Right, for some reason. Oh, wait a minute. Yeah, that's correct. 60898 803 60 E6 FF 60. Right. Let's work. That's all entered. To know where it's crashing, since there's no tooling available for finding that out, again we have to sort of do it in the old-fashioned way. 0350 when I run the code here and it crashes, how far does it get? 035B. There. 26103 and then 4C 04FF. I think so. Clong. I think it's a little more complicated than that, though. That is true, but I'm not sure that's the reason why. For me, it's the idea of simplicity. It's really pleasing when you work on something and you fully understand how it works. So I can agree with you, but it's the bigger the satisfaction when there is a full understanding of how it works. And that here is a pretty damn close to a full understanding. I mean, okay, I don't know exactly how it works in the 6502, detail for detail, but I tell you, if I wanted to, I could build a microprocessor. I said this once in a job interview. I think they misunderstood what I meant. I said I can build a computer. I didn't mean I don't mean just buy the pieces from Amazon.com, video card and no, I could build it out of discrete components. It just would take a lot of effort, but I could do it because I understand what is going on. Not the detail of this particular microprocessor, exactly what the circuit is, but I do know that I have a map of how this works. And then on top of that, I've got just instructions. And so the ability to fully understand everything, that is there, and that's the satisfying bit. Then it's possible to. I mean, really, honestly, this was for me. What's really amazing about what I'm doing right now, to me, is that it's like coming around full circle, because when I last programmed this device 40 years ago, I was just a beginner. I was teaching myself how to program, right? I didn't know about coroutines. So I invented coroutines for myself. I didn't really invent coroutines, but I invented something for myself that were in fact coroutines, but I didn't know about the prior invention of coroutines. I did this in Goal. Goal uses coroutines implemented in a macro assembler. It was only many years later, I think 2 decades later, that I found out that the things had a name and they were called coroutines. It was like a long time later I figured that or found that out. And so I've always been fascinated by the problem of coroutines. It's really a big, really interesting thing, because they're practically impossible to implement. Well, they're very difficult to implement. They're impossible to implement elegantly in C and C++, until recent versions of C and C++. It's becoming more elegant, but it's been really, nightmare. So then come around full circle to on a 6502, the first processor I ever programmed, to be taking that technique all the way back here. And then what do I see? It's like so few bytes. You see the implementation, okay, it's broken at the moment, but the implementation is basically there. I just have to debug it. Look how many bytes are there. This is stupid. There's so few bytes. It's a few bytes. Just a few flipping bytes. And you have a coroutine. That is very satisfying. But it also makes me go, what the hell went wrong with that whole theme? Or as I used to say, 8K. I think it was 8K, was it 4K? One of the greatest games ever written was Star Raiders. Yeah, fits into 8K. It's an amazing game that fit into 8K. 6502 assembler, Star Raiders, 8K. 8 times the memory of the Acorn System 1. But in the ROM. But packs so much stuff in there. And now yeah, it's like you'd be lucky if you can write something, if you could write a hello world in less than 8 megabytes. Yeah, that was, yeah, I was aiming for a laugh. I was aiming for a cheap laugh on that one. I interviewed once at a company that manufactured sort of network hardware. And I thought it would be, I didn't get the job, but I thought it would be, you know, really easy for me to get the job. Why? Because I understood hardware. And this was code for hardware, and I could even program in assembler. You know what the weird thing was? That the fact that I could program in assembler went against me. Why? Well, of course, there was this guy who interviewed me. He went, well, of course we don't program in assembler. And I was thinking, great, I'm not getting this job. Because the company that prides itself on a, you know, high performance. If you're writing software for a device, isn't that one of the instances you can hit the hardware? Isn't there an argument that if you are hitting the hardware directly, since the most critical code is only a small amount of the code that you need, that you only need to optimize a small amount of the code to get like 99% of the benefit. That little bit of code you could write in assembler, making use of the hardware 100%. Same spirit as those you know, demo scene things. But no, I found that very interesting. But it was there that, you know, I was trying to point out, I know how stuff works, you know, very good, I could do that. It's like, we don't want your sort around here. I mean, you know, it's also because coming from a game development background, and there's a lot of snobbery in there as well. Though, to be honest, in terms of rigorous software practices, the video game industry probably doesn't have a good reputation there, so there you go. Did I ever code on the VIC-20? Yes. I wrote a very simple game in BASIC on the VIC-20 at school once. I didn't like the machine very much. Although it did have character, I will say that. But I did program the BBC. So I made a game called... And so programming in BBC, this is 6502, but with assembler, of course. I made a game called Astro Tracker. Oh! And amazing how these games survive. Astro Tracker BBC Micro. Let's have a look. This is my game from a long time ago. Called my company Micromania. So this is a game. So this is 6502. When would this be? About 1981, I think. Two-stage explosion. Waiting for a blank area to drop you in. There we go. Drops you in. I'm not sure the sound effects are right. This person playing the game doesn't like to thrust around much. You're just sitting in the middle of the screen. You can move, you know.
Hello, Dino.
I always loved it when you get the pressure of the thing coming at you, and you knew it was going to hit you, and then it did. Ooh, use the hyperspace. So I was like 16 when I wrote that. It was quite difficult to get the code in because it was written in assembler, which is fair enough. But the problem was that there wasn't enough memory to hold all the code. So what I had to do was break the code up into parts like a library and had them linked together by hand. So I think I ended up with three parts loaded off cassette tape. There would have been the graphics side, the game side, and probably the wrapper to hook it together. So I think it would get more intense over time. Oh yeah, that was a classic. I did that many times. Those things that are moving make that noise. They're moving randomly, but they have a weighting. So they move randomly, but towards you. Ooh, ooh, ooh! Look at that. Nice use of, nice use of the old hyperspace there. Oh, you're going to get shot by that thing. Or maybe not. It's getting a bit crowded. Really? He's good. He's doing well. He's good. He's playing well. Oh, game over. Your score is one of the 10 pace best. There we are. And there's, you see, I've always loved puns. Press hyperspace bar to start. But that was done without coroutines. Hey, thanks, Scott. I did another one, which was a kind of a cross between Asteroids and Defender. It was called Bandits. That also exists out there. Yeah, it's good to see that. So, what am I trying to... Oh yeah, I'm trying to figure out this thing. So what I could do is, when I execute the jump to monitor thing, 361, it executes this. It probably crashes. Well, let's not make an assumption. 0361, I'm going to put a return address there. And this should just not crash, but it shouldn't do anything either. 035B. Okay, correct. It doesn't crash. 0361, we put that back to 20. 0403, we come to the A9, and if I put a 60 in there, I bet it crashes. Yes, it does. So we get an immediate crash on 24803. Why? 20. Yep. So what this does is it loads that address, increments X, pulls A, oh, thank you. Yes, very good. Thank you very much. Sorry. Yeah, that's easily done. I'm going to do a transfer X to A and then push A. If I do continue address, see, how can I debug that? I have to pull A and then push A. Transfer X. Let's check the opcodes. I think that's probably a good thing to do. So if I'm looking at the old opcodes, A6 is load X0 page with what's at address 26, and we had E8, which is increment X, then 8A, which is transfer X to A, and then push A, which should be 4.8. Yeah, so it's a tricky thing I'm trying. We can look at the address 26. We can see that it's 6.3. Oh, maybe I don't need to add one to it. I don't need to add one to it. I think that's the problem. Maybe I can just put an EA in there. 034A. 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 Oh. Yeah, sorry. If I lean back this way, I can't see the bottom digit, and it makes an 8 look like an A. That was confusing. E8, EA. It still crashes. E8, E8, increment X. Maybe I have to decrement X. That's 8.8. No, 8.8 is decrement Y. Decrement X. Dex is CA. To 034A. Try CA. That still crashes. So to understand what's going on, what I could do is just change this function a little bit to for debugging purposes, and just see what I pulled off the stack. So I'm going to go to 0347, 0347, no, 0347, where I had this 6.8 instruction, which is pull A, and then instead I'm going to store what was pulled off the stack at address 26, and then just return. No, that won't work, that'll crash. I need to push A back, so I can do 4.8 and then 6.0. I'm just 0347, be 6.8, pull 8.5, store it at address 26, and put it back on the stack and return. This should not crash. It still crashed. Oh, you watched Bandits. Well, Bandits. Yeah, I didn't. I tried to sell Bandits through Bebug, but it weren't really that interested. They said it was too similar to Asteroids, and that was when my cynicism of the video game industry already began, when I was so young, because it's nothing like it. It's a different game. The only similarity is it has the same kind of ship. Bandits, interesting. There are certain innovations that I did in that. BBC. I mean, Bandits didn't even get... I don't think Bandits was ever properly released, to be honest. I must have been released. I can't remember now. For sure. Where's the video? Oh, 1983. Okay. Yeah, because it was after... Oh yeah, it was published at Oak Software. It was a company that I had with a friend of my father's. Bandits Hall of Fame. And look, it has an attract mode. And you can see the inspiration from Tron. Oh, come on, you can play better than that. It was difficult then. It's brutal. See, it pick them up even when they were falling. I was quite proud of that. Yeah. It was yeah, maybe I should dig that out again or make a new version of it. What's this? I think this is my own video. Bandits. I was playing it. Someone on the Twitter feed found a game, so I did actually mode. Odds off moving much, and there's yeah, and oh look, and it's pretty fast, isn't it? Now how do I rotate again? I was playing it for the first time in a long time. So you can see some cultural references in here. Yeah. Anyway, it was certainly inspired by... You could tell that it was inspired by Defender and a few other things. and it had an enemy that was the diamond. When the diamond enemy came, you had to be really on your guard because it would just move like this. But at any moment, you didn't know when it was, it would just change and come flying at you really fast. And it's quite a dangerous enemy. My camera has gone really weird again, hasn't it? Look at that. It's like I'm in a smoky room all of a sudden. What's going on with this? Logitech, do you have cameras that work? Clearly what I need is bright light. Obviously bright light thinks that the right light is for me to be completely invisible, not visible. What the hell? Oh, right, okay. Alright, well that'll have to do. That and Citadel was favourite games. Wow. That's quite a compliment. If Citadel's the game I think it was. Alright, why is this still crashing? It's like 035B and then I do jump to 0361 and then it jumps to 0364. And I have a return statement in there. So that's fine. 0347. Pull A. Store A at 26. Push A. Return. So since this is all failing, what I'm going to do is just EA it all. 6-8. So put knots in. That does not crash. You know, that's really good because I've just blanked it out. I'm going to try to debug why this doesn't work. So if I do 6-8, which is pull A off the stack, pull the byte off the stack and put it in A, and then immediately do 4-8, which is push A, it crashes. So well, there's a problem. Pull A, push A. Shouldn't crash. You shouldn't do anything. Hey, thanks, Klong. I'm glad you enjoyed it. Thanks for watching. Have a good night. Take care. Yeah, so I do a 6-8 and a 4-8. Pull A, push A. 6-8, 4-8. So let's check in here. 6-8. 6-8 is PLA. 4-8. Push 8. Let's have a look at the manual pages for that.
Good night. Good night, Zag. Thanks for watching. Where is that thing? PA, pull A. So push A. Pull A. They should cancel each other out and the result should be fine. 6848. Pull A, push A. That's really strange that doesn't work. Up 347. Pull A. Oh, I wrote the wrong dress. Look at that. I should be at 347. I put in 348. I'm out by one. How did I miss that? 036. That's a silly mistake. It should be 47. And that 370, that was also wrong. This is the then do. Then do is 3440, not 48. So this should be 40. Which I've just fixed. I only have 2 then do's in here, and this should be 47. I was out by a byte. So of course when I put all the A's in there, it didn't matter. I can do that with a 0361. Okay. 0347. 0347. 68. 68. Let's make sure it doesn't crash. No, it doesn't crash anymore. Right. Now I need to put this code back. 0347 68 A626. A626. E8. 8A. I never really talk about those old games when I'm job hunting, because they so long ago. Didn't really help. It'd be better if nobody knows. A963. Fortunately, I'm not job hunting. It's horrible when you're job hunting. O362 24703. Let's see if this crashes. No, it doesn't crash, which is good. I'm going to put the code back now. 364 0364 A9
A901 85FF 20400360 A9 0285FF 20400360 E6FF60. Doesn't crash. Excellent. I think that was it. It was a silly mistake. Off by 1 on a jump. Now, let's rerun the test. 0350. And then go. 0350. Go. Then what we need to do is start testing the execution. 035B. 035B, and it did not crash, which is great. Now we've got to look at the code, the value in my debug variable 02. Well, that's interesting. That was almost, it almost worked. It's like, it should have been 001, not 02. If I run it again, oh, but it is, it's getting there. Look, it's incrementing now. Every time it increments it. So, increments it, right. So let's just try running this again properly. 0350, go. Its debug byte is 0. Okay, then I run once at 035B, 035B, go, memory 02. So, for some reason, it jumped to here in one go. That shouldn't have happened. So close. 0368. If I look at 0368, we had 204003, then there was a 60. That is very odd. Oh, 0350, go. Memory location. Oh, hang on, I just wiped out 036B. You've got to be careful of this. 036B, you should be 60, not. Right. 00FF, we've got 0 in there, and 0026. We have the address 63. We go to address 035B. And now we're pointing at 72. How did it get to there? So I think the problem is that I shouldn't be increment. Yeah, I still think I shouldn't be incrementing that. Let me check that. 034A. 034A. That E8. If I make that EA. Now I'm going to have to run this again with 03. Go, and now we execute 035B. Oh, that's crashing now. I must have corrupted something. O34A. No, something's corrupted. 0340. We have to check memory. 0340 BA. BD0101852660. After a while, you just learn them. 68A626 E8 8A 4860 A9. That's wrong. A900 85. I think it's fixed now. It was just a. Okay, fine. Modified something by accident. We go and run init test init exec 035B. And then is it 7.2? Yeah, it's weird. It's how did it get here? Very close to working, but there is a little bug. Ah. 3 A. Oh, it's E8, not E8. Oh, because I changed it back because I thought that was okay. Run the test again. 0350 go. Now 035B go. Memory address 00FF 01. Aha! It looks like it's beginning to work. So I ran the coroutine one time after initialization, ran it once, and my location FF has 1. So it's set FF to 1 and returned. The next time I execute it, this is the big one, next time I execute it, it should not do that code anymore, but bypass it and do the next piece of code, which is going to set that value to 2. Didn't crash, that's good. And look at it, oh, it's still 01. And so it's actually stuck, I presume now. We'll have to see what the address. I'm really hopeful that was working. It's stuck at 6A right now. Yeah. It's stuck at 6A. Because it's actually jumping into this return statement. Which is why I had the increment X here was to make it not do that but jump to the next instruction, but then it seems to Oh, I made a mistake. Yes, there's a... Oh, I've seen it. Right, I do need the increment X. But what I've done is I pushed back onto the stack. Oh, hang on. No, I thought I had it, but it slipped away. Yeah, incorrect X, transfer X to A. Oh, because I've... Yes. No. Wait a minute. Then do is here. I've got the two things confused in my mind. Oh. Yeah, right. So this one, transfer the... So I get the value from the stack. I store it in 2.6. This was after the first call was set to 6A. So what happens in here is that I take that 6A and I add 1 to it, so it make it 6B. And 6... Hey, I should jump to O2. It should be working. So I initialize it, 035B, I go again. And now we're at 6A. But I add 1. I need the add 1. Okay, so that is 034A, which is, it is doing the add 1 now. EA. No, she's E8. It's not, right, E8 is the increment. Right. 0350, go to initialize 035B, first time executed, 0026 contains 72. So that's really odd how it seems to have skipped one of the states. It went straight from 6B, 63. Oh. Now, when I do the exec, it's going to add 1 to the address that I put in there. And the initial address is 63, so it makes it 64. It'll actually jump into 65. I think I got that. I'm on off by 1 error. The address that I put in here to say execute from 6, it should be literally, it should be 64, not 63. I thought it needed to be 1 less. So this jumped to 26. That's 64. 64 is this 0364 should jump to here. I'm going to give that a go. So that is changing 0355 address. 0355 memory address is 63. We're going to make it 64. Let's run our test. 0350 go. And then 035B go. Didn't crash. 0026. We're now at 6A. So we were at 6.4 and the virtual program counter is now at 6A. Yeah, but let's see what's in the.
Still not quite right. 2-6. No. 0-0 FF.
It's 6-5. It's some random value it shouldn't have had. Right, so I'm not sure where it's jumping to. Does it? It's not jumping to the right place right now. Oh, I know what I can do. If I change 0368 to a return statement,
So I'll change that to 6-0. What that means is that
it will only, if it executes this here, it will just then return and it will never change from that. So I basically reduced the test case down, simplified it. Let's make sure that that works. Probably won't. 0350 go. 035B. Yeah. 035B. That twice. 035 go. 035B go. And then we have to check the memory. 00 FF. No, it didn't set it. The 0026. We're at 64. And it didn't set it. So I think this does need to be 63. 0354. It must be 0354. 0350 go. 035B go. And it's 02. How can that be 02? Unless I've thought it wasn't working because of a damn typo.
It's very odd.
It's at 7.2. So the current execution point is here. So it would continue from there. How did it get here? That's very odd. If it did execute 0364, let's check that. It's A901.
ff
60. It's not making any sense.
So we have to simplify it more. EA
Up to
7.5. EA
7.5.
EA 6.0. So I've just knocked out everything
between 6, 8 and here. I've just blanked those out.
Help me understand what's going on. 035B, go. 00 FF contains
0. So it failed to jump here.
Oh, 354.
Put this back to 6.3. So let's think about it. In address at address 2.6 there'll be the number 6.3. When it comes here and executes this, which jumps to 0347, 0347 here, it pulls something off of the stack, and it's going to be, I'm making an assumption of what it is. I'm going to modify this so that it saves that at address 2.6. And exits. So the best way is to do 0347 6.8, pull the accumulator to the accumulator, pull the byte off the stack to the accumulator, and instead of that I'm going to do A526. I'm going to store it at address 2.6 and then follow it with a 4C 04 FF, which is like an exit, is returned back to the operating system.
0350 go 5B go. If I look at the 0026, I'll see what was actually on the stack.
It was 6.3 on the stack. Which is correct. It's this address here. It's the address I expected it to be. So it should not be incremented. Oh, wait. Six 3 would be the next instruction. So when it returns, it should it needs to be 2 bytes. Less. It needs to be 6.2 because normally there is a 6.0 over. Yeah, okay, I think I see the problem. This is the issue with this type of thing. You really have to nail everything down, but that is actually, I argue, not such a bad thing. At least that's the theory. If you make life too convenient, what happens is that you stop building your muscles, your mental muscles. I think what could have happened is that all of these fancy tools that we all work with, you know, like autocomplete and so on, they're really convenient and everybody swears by them and it's really great, but it's a bit like everybody, or lots of people do,
it's like relying on physical support devices will eventually cause your body to atrophy. So the cost of it's the theory, we put 6.2 here. So the cost of convenience can be that we don't keep fit. It certainly happens physically. Now I'm arguing it happens mentally as well. So that's one reason for the decline, possibly, of programming skills, is that we don't keep fit. So at this point I blanked out everything else. What I've done is I've reduced this by another. So I need to put an address 62 2 bytes before where this is for the initialization part, for the first part, because one is required because that's normal for the mechanism, and the second one is required because normally you're jumping over a return state. Let's see, go to 0350 go, yeah, and then 035B go, and we check memory location FF 01. This time it executed it. I think we're there. I just need to type it, the code back in. 0366. It makes sense though, doesn't it? I mean, you know, if you don't keep fit, and then you know, you lose your edge. 0368 20 4003 64 A9 01 85FF 204003 60 A902 85FF or put another analogy, it would be like if there were musicians that could play musical instruments, but then eventually they rely on machines to play the music for them. This is exactly what has happened. What you get is a decline in the ability for people to play musical instruments. Let's try 0350 go, and now 035B go. It didn't crash, which is great. We'll go and look at the address. FF is 01. Yes, this is looking good. Now the second time I call, what I'm hoping is it doesn't crash, which is right, and if I go to the memory location I have 02. This is a coroutine actually working. Oh my word, this makes me happy. If I run it again, 03, and now I don't do any more then do's. It's just going to continue here. So there's what the coroutine is doing. It's like having a virtual pointer. In the initialization, I've set the pointer to here. When I call the test, it runs this, which stores one at location FF, and then it calls this then do, which plays a little trick, and it calculates what it needs to put in address 26 here, such that the next time that this is called 0347, this code here is called, the next time that is called,
it will jump precisely to here. This is a virtual program counter. It sets that up and then it returns. The return means it goes back to the operating system in this case. When I run the code again, it jumps obviously into here, which jumps to here, and this subroutine plays the little dirty trick of changing the return address to what was remembered, which is here. So from the next instruction it arrives there, skipping out this part, sets ff to the value of 2, calls this function again, and then once again it will take this thing and say, what is the address past me, put it in, there it goes, it puts it, points this to here, returns back to the operating system. Okay, I call the function again. Now when it gets to here, as before, it executes, it uses the current pointer, plays that trick again. It doesn't return to here, it returns in fact to here, where it increments the value ff and just returns back to the operator. Now every time that I call it, it's always jumping here, and so in the end, every time I run, it's just incrementing it by 1. That's a coroutine in I've written coroutine implementations in practically every language, every language I ever use. Now I've finally done a coroutine implementation in 6502 assembler. I'm feeling really pleased with myself. Like you don't know. This is great. And what's really nice about it is I can use this in my endless runner on the system 1 to do lots of things. Basically I don't need to have a silly or a simple state machine anymore. I've actually got it's only one level though. No nesting as yet. If I want nesting, I need to do a full implementation, nestable coroutines. That would be an interesting exercise. Starts making me wonder what wonderful things could be made on a 6502 processor by use of coroutines, something I didn't have in my toolbox when I was doing it last time. There are people who've written multitasking operating systems in 6502 as a kind of exercise. That's crazy. It's difficult to do because there's only 256 bytes of stack space. If I were a teenager now, do you think you'd start coding like you did growing up in the 80s? No. No. If I was a teenager now, what would I be doing? If I was a teenager now, I'd probably be trying. Well, it's like, everybody wants to grow up to be a YouTube star. I don't know. I don't know. What inspires the young people of today? Did I mean what inspired the young people of today? No, what inspires I didn't misspell anything. And it's amazing. I'm having trouble finding. It's not a strange question. There you go. There's your answer. It's hardly a question. Everything you get is like inspiring the next generation. WWF 10 inspiring young people to follow in 2020. No, that's not my question. My question is, what inspires the young people of today? Inspirational youth, that's not the question. A society to inspire young people. As a young person in Britain, I read Will Hutton's article with both despair and relief. Young Britons have been hit hard. We owe them a future they can believe in. They just need to believe in themselves. That's what we need to do, is we need to allow people to believe in themselves. That's the actual problem. Everyone's full of doubt, self-doubt. Relief that the palpable challenges facing. I'm saying that because I was. So I think it's got. I imagine it's got worse, not better, as an issue. I've experienced the meritocratic messages given out in formal education, both sides of the fence. Not really answering the question. I don't know. I don't know. It was, the video game industry started with, in many ways, look, when I started programming on that was about 1979. I was about 13. I was doing stuff that the world had never seen. This is not that sounds grandiose, but it's not really. It wasn't just me. It was lots of people were doing it. One of the motivators for us to work with the technology when it first came out was this feeling that we were doing something that had never been done before. And we did. It was pioneering. This beautiful little thing, which gets, for me, gets more beautiful the more the more I look at it. I don't know. This is a beautiful thing here. This it looks innocent, but this was a big deal in the end of the 70s. To own a computer, even one, as simple as this, to own this was the first time that computers had entered the home. You can't, but people don't perhaps think about it, but it's like it's a huge, huge deal. And these days, there are computers everywhere. Every home probably has several in different forms, from phones to actual computers to, or devices. I mean, even your television is a computer now. Computers in the home. This was the first computer that entered my home when I was a kid. that crossed the threshold of the door, and it didn't even cross the threshold of the door. The parts crossed the threshold of the door, and then I built it. I had to solder it together. Not this particular one. I lost my original one. No idea where. We don't know what happened to it, where it went. But it was a huge deal. And one of the inspirations was amusement arcades, because they had video games, early video arcade games, and also pinball machines and things like that. And people couldn't always get access to these. You had to be in the right place to get access to arcade machines, and even if you did, you needed to have the money, and they were expensive. You couldn't keep putting, all your money down into these things. So there were some huge motivators there. There were also a few distractions. You had TV. Having said that, TV was a huge distraction. Everybody was watching TV all the time. I'll come home from. This is part of the the institutionalization of children, from the whole way the education system works. You go to school. You'd spend a day atrophying mostly, or dancing when you were told to dance, or whatever, and it was like a job. And then you get home, and then just as it is when you're working in a job that is tiring, you drained, and you watch television. And I watched so much television as a kid. We all did. There wasn't anything else to do on a certain level. What could you do? It's like you're living in cities where, I don't know. And back then,
Hello, Dino.
hello. But the thing is, now is even worse, because there's a greater fear. Everyone is more afraid. We had the desire, therefore, to create. We were looking for more, and what we found more in was the technology that was I think a major escape or focus, or an idea of something to do. I also found music to do, but I never had anywhere to play it. It's like you just yeah, music came later. But yeah. So you've got this thing, is technology, that kids were working. And it's something that they could do that their parents couldn't do, or probably wouldn't do. So, but for me, it was even further than that. It was just because I was always interested in technology. My father was an electrical engineer, and he would bring home stuff, and I just loved gadgets. I loved building things. I especially liked things that moved by themselves. So I had some pretty strong motivators. Even before, computers arrived, I was making electronics stuff. Then of course when computers came along, and that took my attention. I imagine. No, let's be fair. Having said all of that, let me give some encouragement. It's unfair to think about it as being quite so. You just need to go to YouTube and you go, Signs of life. There's some pretty rubbishy ones, but oh, Fran Lab. So this is she's been doing this for a long time, and I think it's got kind of a notable following. I mean, her videos get quite a lot of views. Probably not making a tremendous amount, but helping her something, actually getting something out of this, and she's been doing it for a long time. 156,000 subscribers. Who are the people watching? I don't think there are. I think there are a lot of young people who do. We can look at Mr. Carlson's Lab. YouTube channel. So,
Hi there, my name is Paul, and this is my lab.
look at that.
In this series of videos, we're going to look at all sorts of different... My name is Paul, and this is my lab.
This is his lab. I mean, look at that lab. I mean, that's just... So he's doing pretty well. And what does he do? Oh, look, on this picture he's got them all turned on. I didn't notice that before. All of it is all turned on. My word. You see, and this is... He restores electronic equipment. And... some of this stuff's really... Look at these oscilloscopes. They're beautiful. The point is that there are a lot of people interested in this kind of stuff, and it isn't as a career. A lot of it is just because they're interested. There's a lot of this going on right now. Kind of call it vocational entertainment. You know. Nephew in grade school, and he takes a lot of programming classes. Scratch to make games. I was pretty lucky living there with climbing trees and stuff. That's always good.
In this series of videos, we're going to look at all sorts of different kinds of electronics. Solid
Look at that.
state and vacuum tube electronics. We'll look at RF circuits and audio circuits, intermediate frequency circuits, digital circuits, and we'll get into some theory. The whole idea of this channel is just to really make electronics easy to understand and fun to participate in. So let's get into the videos.
So there we go. I quite like watching his restorations. So I don't think it's anywhere near as bad as it seems. I think it always feels bad. It depends where you look. Because then, you know, you've got that, but then you've also got Cutie Pie, don't you? He made the money. He made the money on YouTube. I've got a song coming out. It's called Lottery. Yeah. Anyway, you know what? I think I have to go to bed as it's getting late. There's still 4 people watching, I just saw, at 3 in the morning. That's incredible. I have co-routines. I do need to save this before I go. So, Audacity. Where are you? Oh, there. Let's mute this. Let's have and add a new mono track. And I'm going to record. I'm going to save the memory of this thing. There we go. And save. It is writing it. Ah, it's back. Stop that. Save the project. And we'll end tonight with Man with a Mission. Why not? Thanks for watching, everybody.
I'm a man with a mission.
Until next time, take care.
I'm a man with a mission. 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 I'm a man with a mission.